This is an episode of For Plumbers Only, and we are going to be reviewing a set of construction documents for the plumbing plan and for the plumber, and we're going to review. This is a project from the ground up, so we're going to review first the utility plan, and that is the plumbing that would take place outside the building, and then once the plumbing gets into the building, then of course we're going to look at the individual plumbing plan. And so this is a very small, same little project, this coffee house that is going to be built from the ground up. And so what we're going to look at really is everything that's related to the plumber scope of work. So WL, that's the water line. And so what we typically do, right, is we tap into the utility line wherever the public utility water line is running along the street, which they do, right? We tap into it and then we bring it into our new building. And then underground utilities are always, well, it really depends on the state, but we're going to assume PVC and for the underground utilities until it comes into the building. So what we always do first is look for the scale. It's the same scale for 1 inch. It is 10 feet. We've already scaled it. That should be 5 feet, which is correct. And so for the plumber, what we're going to do is just look for all of the plumbing scopes of work, everything related to the plumber. And so we have the water line, and the water line is going to tell us, we're going to look somewhere, it's going to tell us the width of the water line. Okay. 1.5 inch. That's the water line. And that's why I like looking at these when I do the recording. So I don't whip through them, right? I have to take my time. So we have the water line, and then we also have an irrigation line which is, probably the same PVC. And so what we'll do here is WL, our water line. You know what? Let me go back because it's hard to see when it's not caps. So our water line, and we know we're going to go back and so you see all the angles, right? We know that we're going to have 45s and 45s, right? Until he gets into the building, water line. Yeah, let's see, where else? Sanitary sewer, SS. Okay, and it's going to tell us somewhere what the size of that is too. So, it's a 6 inch. So we don't care right now. Well, we always have to go back and check. So we'll see the SS, and it's going to come here. Proposed sanitary sewer. Yep, all the way here. This is some kind of manhole test system or something. It should be noted though if it's something that we need to really look at, like this one. E, that's electrical. So our utility plan has the electrical, right? But our electrical plan's always gonna have its own site electrical. So just in case the site electrical is missing something, we don't really need to look at this one for the electrical. And then I'm going to take this all the way to here. And now this is a 6x4 reducer. Okay, so I have to account for that because that's part of my plumbing scope. All right, that's that. Now, what is all this is what we want to talk about. So that's that. So basically what it's telling us is a 6x4 reducer. And this is giving them the elevation of the 4 and the 6. Okay, just a little off by what? A tenth of a m, whatever this is. It's based on GPS coordinates. And so that's what all of that is. 6x4y. This is the GPS coordinates. So when they set it, they know exactly, so it'll fit to where we're setting the pipe because the pipe is run Then we have to set it into the component, right? And sample, propose sample well. That's our plumbing scope of work. It's 4 inch. Okay, and then we have a grease trap. It's the grease trap. That's also a plumbing scope of work. And it looks like this is a 4 inch, right? Because this is the grease trap. Okay, it has two, one in, one out, in and out. And there it's telling me it's 4 inch. So I'm just going to go ahead and I'm going to say the grease trap. So GT 4 inch. So I know this was what was going in and out of the grease trap. And you know all this is underground, right? So I'm just going to go through for waste purposes. Right, so this is a 6x4, so this is got to be the 4, and the other end is the 6. Okay, so plumber, site, work. Let's see, that we always take our time. And then, yeah, we have to count for meters. And yeah, the size makes a difference. So the irrigation meter is an inch, and then the domestic water, domestic, I'm sure, domestic, I don't know. I'm not thinking. I've done a million of these today. So that's, yeah, for the water, and that's for the irrigation. And the irrigation plan is also, I have to look on the landscape plan. It should also show our irrigation on the landscape plan. It may not because it's showing it here and they're trying to get more bang for their buck. So it may not. So as far as the plumbing, okay, grease lines, 4 inch sewer connection, 1.5 inch water line. Yeah. So that's once it comes into the building. So now we look at the plumbing plan, right? Because that's once it comes into the building, we transfer to the plumbing plan. So that's the plumbing specs, plumbing notes. So what are we going to be installing? So we know we have the sanitary waste, water, condensate pipe for our HVAC equipment, indirect drains, okay, and then the kitchen equipment, right? Anything related to the plumbing scope of work. So the ice maker, coffee maker, espresso, da 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 da. And of course, we also always need to know the size of the pipe that's coming in and out, and the vent pipe if it applies to all of the equipment, whether it's the kitchen equipment or the plumbing equipment, the lav, which is the term for the sink only in a bathroom. So when we see lav, we know we're talking about the bathroom sink, and the cold water, hot water, waste, vent. Plumber needs to know the sizes of all of that. So we look through, make sure we know the typical symbols. Da 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 da. Da 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 da. Okay, we got the recirculation pump, mixing valves for probably the bathrooms, right? So we just instantaneous water, instantaneous heat. That's what those are for. So we don't have to worry about water heaters for the bathrooms, sinks. The expansion tanks always got that. So always have to make sure that you are noting all of your plumbing equipment and the sizes of the pipes for water, hot water, cold water, vent, waste. Hold on 1 second. We're going to have a frosty drink for 1 second here. All right. So you have to know all of your equipment because of your rough ends, right? So you're going to have a rough end for every piece of equipment. So if you have 10 lavs, you got to have 10 rough ends. Okay, so you got to make sure. Now we go to plumbing details. We see our circulation, recirc pumps, or backflow preventer. So it's like, oh, I used to take my walks all the time, and then I would see those. I'm like, oh, now I know what those are. You always see those on the outside of buildings, right? These big things, maybe. If it's a place where it's cold weather, they'll have the little green insulation jackets over everything. Construction makes you smart. Let me tell you. All right, so that's so the plumber can see what the elevation views pretty much of their plumbing scope of work is supposed to look like. Typical, right? That's a typical reduced pressure black backflow preventer. So meaning they always use the same kind. All right, so let's get to the plans. So we know the difference between the riser on the left and the plan on the right. The riser will give us all of the horizontal measures. So all we got to do is get to it. Right? We have a two plans for the plumbing. So we have the sanitary, and then we have the sanitary and the vent plan. Then we have the hot water, cold water plan, and gas if there is gas in the building. Okay, so this is just the sewer plan and the sanitary riser. What does the riser show us? The vertical measure of the pipe. And so, yeah, we always need the riser. It's always a great set of plans that gives you a good riser because you can determine because we have to determine our material costs, right? Our material quantities. So, yeah, we need to know for plumbing what's the vertical measures as well as the horizontal measure. The plan is giving us all horizontal measures, right? This is all horizontal measures of pipe. But the pipe go up and down, and that's the purpose of the riser. And so every time I see this is a vent, right? Symbol for vent is the broken line, right? We have broken lines in a lot of cases, so you got to make sure you know the difference. On a plumbing plan, broken line means vent. On a demo plan, broken line means demo. Take it out. Underground uh, uh, on a grading plan, broken line means probably underground utility, and it's gray broken line, underground existing. So you got to know based on your plan what that symbol means. But for plumbing, broken line always means your vent. So this is a 2-inch vent line, and what you'll see on the plan view is the horizontal measure. The riser gives you the vertical measure. That way you can measure up and down and you don't mess up on your material quantities. Every time I see up and down, I say 10 feet, period. Rule of thumb for me, right? Because a building is between floor to floor is pretty much 10 feet. And this is a single story building, so you can give it a vent to roof, right? Vent to roof, you see the vent to roof. That's going to be out the roof, up out of the building. So I give that one an extra 2 or 3 feet. Okay, 3-inch vent roof plus the little vent roof thingy. Okay, what else? All right, for what the riser diagram is very good for is to count your uh, equipment. Sometimes it's difficult to count your equipment from your plan. Sometimes it's okay, sometimes it's not. It really depends. So, but you got to recognize that there are some items that are on your sanitary riser that's not on your uh, cold water, hot water riser. The clean water. I call one the dirty water plan, which is this one, sanitary, right? It's all the waste vent. That's the dirty water. That's the sanitary plan. Okay, you say nothing mentions hot water, cold water going to any of these components, any of this equipment. This is all the sanitary plan. The next plan is the water supply plan. And if there's gas running in the building and it's not a lot of gas, unlike a dental office where you may have a separate plan just for the gas lines and all the different gas that a dentist has, or anybody having a lot of different gas lines, they would probably have a third set of plans for just all of the gas pipe. So this is the second plan, which is the water plan. So all of the pipes go to the same components, different size pipe, 2 dot, 1 dot. 1 dot is cold water, 2 dots hot water. You gotta look on the schematic. You gotta look on the symbols to make sure. And then here too, we have a riser diagram. which means the up and down vertical measure of the water. Same thing applies. It's going to show you the size, and these are the controls. So everything you see here you have to account for it. Okay, and so every time you see it go up, well, I have 10 feet of 1/2 inch, and water pipe is typically the copper pipe unless it says otherwise. And sanitary pipe is usually PVC unless it says otherwise. Sometimes it's cast iron depending on the state and if it like freezes. I know New York, for some reason, I keep thinking New York, everything has to be cast iron unless it's some other, like hotels. Once it enters the hotel room that has like courtesy sinks and wet bars and stuff like that, then you can use a different kind of plastic for those types of situations. But okay, so plumbing, that's why plumbers can't mess around and have somebody that does not know how to do a takeoff. Because imagine if you don't consider the vertical measures. My goodness, you're screwed. And the rough in cost. Rough in cost again is the additional cost for the piping systems that apply to the dirty water plant and clean water plant for the first time that you install that piece of equipment. So when you have new construction, not renovations pretty much, because with a renovation, unless you're installing like an addition that has a brand new plumbing system where a brand new toilet is now introduced into the home or whatever, not just where you took an old one out and put a new one in, there's no rough in cost associated with that. But when you have a project from the ground up, it's very important that you include the roughing cost, which is the additional piping systems for both plans the very first time you install that piece of plumbing. So it could be anywhere from, depending, it could be $1,000 for a shower roughing cost. So you never want to exclude that, and again, especially for new construction like this is. Okay, so what we would do on this one, we just got to get a good takeoff tool. What's the scale? 3/8 equals 1. And we just, you just got to take your time. And like 1/2 inch. Now, I normally don't differentiate cold water, hot water, because I don't have a lot of time in my life for that, because both are the same. But I mean, you might want to go back and do it later, right? So now these little symbols that indicates that the pipe is going up or down. Okay, uh, if you can see like the white, it typically means the pipe is going up. If it's darkened, that typically means the pipe is going down. But that's why you have good riser diagrams. And then let's see what 3 and 4 is telling us. Shut off valves. Let me see. I didn't look at the symbol. The symbol makes a difference. Oh, and I don't know where I was. Okay, no. Octagons. I gotta look for the octagons. There's an octagon. Okay, right. 3 and 4. Yeah, yeah, that's just shut off valves. Has nothing to do with whether it's going up and down, because you have the awesome riser diagram. So the riser diagram tells us it's going up. And so you can account for that way. All right. And so I guess that's it. I mean, if you're doing this, take off, this is a good project. Civil plan, underground utilities. Once it comes into the building, you switch to the plumbing plan. And the main thing is to understand, don't forget every time you see a pipe going up, make sure you know the size of it. 10 feet, 10 feet of 1 inch, 10 feet of 3/4 inch, 10 feet, right here, 10 feet, 10 feet, 10 feet. Now remember, the horizontal measures are what's on the plan. So you're only looking at the riser diagram for the riser, right? The up and down, the vertical measure. These measures are the horizontal measures that in one way or another are reflected on the plan, in the plan view. right? So if you have any questions for this, please let me know. Please sign up for our class for plumbers only. It's $9.99 a month, and we add new content every week. If you have questions, you can sign on and have a like a office hour where I will answer any of your questions. If you like the video, please let us know. And we are running some specials. One, October 15th, a $100 Starbucks for all of our nice listeners, and then also free training, a contest for free training as a Thanksgiving present. And for Christmas, we're also giving away every month some free estimating if you have a company that requires estimating. So you can lose one way or another. But if you have any questions at all, please email me at education@sfjohnsonconsulting.com, and I will talk to you soon. Start. All right. So we are going to first complete the floor plan because we are going to complete a cleaning estimate for a client. And also, we are bidding on this ourselves, so we are always looking for all of the trades: framing, painting, drywall. In this case, concrete, because this is from the ground up, and we'll also be reviewing the foundation. And so, let me make sure we have everything set before we start. And the first thing we always want to look at is the scale and make sure we have the scale correct. And so what we're going to do right now, before we do the foundation actually, because this is pretty much easier to do, we're going to look at all of the call outs, detailed call outs for how it's going to probably, who knows what it's going to show us, because I don't try to look at it too much in advance before we do the estimates. And so we're going to first see, we have here, we have wall here, but a lot of the building is a storefront. And so what I'm going to do is I'm going to separate the storefront walls from the main walls. I know that I'm not going to deduct an opening, because if this is the storefront walls, which we will look at the exterior elevations to see how that's built and everything, I'm going to separate these walls, the exterior walls, load-bearing walls, from our storefront window walls, because the wall portion is going to be totally different than if there are no openings or if it's not the storefront. And so I'm going to call it storefront. As soon as it catches up, I think it's doing too much. Oh, come on, computer. What are you doing? There we go. Storefront walls. Because those, in terms of construction now, it's going to be a lot different than the other walls. And then I am going to go through the door there. Because, too, we're going to do this for final cleaning. And the final cleaning is going to really have to clean both sides of the windows. And so that's good for that, too. Looks like these are also some kind of window. It's a drive-through, most likely. All right, so let's just finish the exterior walls. Am I spelling right? I really don't care half the time if I'm spelling right. Because I know what I'm doing. All right, so we're going to go through that door. We're going to go through all the doors because in terms of the wall framing, it's waste, and usually if it's less than 16 feet, we go through it anyway. And so we'll go there. So those are our walls. Now, what we're going to do first, let's see how our walls are built. So 4 over A 4.1 is what we're going to look at. Image number 4, page A 401. 401. Image number 1. So that's image number 2. Are we on page 401? Yeah. Okay. So all of the walls are pretty much this height to the roof joist, and this is the exterior. And we'll look at what the keynotes tell us. 2, 5, and 7. 2. Frame wall with that insulation, typical, so all the way around. 5. EIFS system, typical, and 7. Pre-finished metal coping at, so that's for our roofer. We've got that there. Parapet. So we have exterior walls that are, let's scale that, 1/4. This is very easy because it's a shell, so it's not really much that we need to do. And so the walls to the roof joist, that's what I want to know. Wall to roof, because our framer needs to know how many square feet. 14.9. So we're going to have to say 15. We'll just give it 15 feet for the exterior walls because they are different at different heights because it kind of goes up. So let's just do that one too. I'm going to use a dimension tool for that one. So just to the roof joist, 15 feet. Okay, so, and then the parapet wall is an additional, because we'll need that for 6.5 feet. Okay, so that's pretty easy. That's easy. All right, so going back here, we know that we have exterior walls of 145 feet times our 15 feet, we say. So that's how many square foot of framing, and we will have a professional estimate created from this takeoff. Okay, and so the framer is going to do that. And let's see. I mean, we need some, let's see. We got to have some more details as far as the walls. So that's the storefront area, all of that window. And so final cleaning, we know we're going to clean both sides of that. So that's easy. And then there's some other drive-through window. And so if I'm going to do windows real quick, which I probably will do real quick, let's do the scale, 1/4. Because we need to tell our windows, our final cleaner, how many square feet of window they're going to be cleaning. So this appears to be window. And if it's not, it's okay. We'll deduct it. And you know what? We're going to go through. All of that is going to be window. Because we got to clean it off anyway. And this is our exterior elevations. And so that appears to be window. We got to clean the door anyway. And all of this is times 2. And then we get this little window. Because we got to clean both sides. And so we'll make sure we have 4. It's like 2 no, that's 3 elevations. Make sure we have all the exterior elevations. So we can make sure we have all as many square feet of window. And you know what? We're going to include that whole thing because we have to wipe all that off when we do our final cleaning. Okay, so let's see if we have any other. One more page that has just the, no, that's the building sections. So that's okay. So, okay. And so we have that. We have the framing, roof plan. We're going, parapet cap. So now we're the roofer, and we need to know, we need a couple of things for the roofer. First, we got to scale it, and we have to tell the roofer how many total square feet of, I think it's TPO roofing, because we are going to bid this. So if you would like to bid this with us, we would love to have you join us. And we do all your estimates too. When you work with us, we do all your estimates. And we always win. Why? Because we are the best. And then what we do too. So we have the total square feet. But what we want to also do, remember this is a shell. And so we're going to deduct roof openings because, our roofer asked that we always deduct the openings from our square foot total of roofing material. And so we're going to make sure we do this. Isn't this exciting? Isn't it so fun? All right. These people in our country, they need to just do estimates and be happy. Oh, let's go over some more. All right, so the purpose of that is, we're a little off, but that's okay. So roofer, with the roofer then, so we just finished what the framer needs real quick, right? And hood below. This is a big one. And what we also need is, because we'll have to flash the same openings, we really need to know how many linear feet. But because my tool I did point by point, point by point for each of these squares. See how that square is 28 linear feet? That square is same thing, should be right. Same 28 linear feet. So I don't have to do the linear feet. I could just do that. 7, I'll round that up to 8 linear feet. 9, 8.5 linear feet. 12 linear feet. 43. So that's the flashing. See how great that is? And then let's see what number 9 is. Solar ready. All right, so I'm just going to do this area just in case they need it for something special. Just in case I'm asked to price a solar panel or solar something. Solar is weird how they price it, so I'm just going to do that just for the heck of it. So I'll know. Just in case they need it. Oh, look. Forgot that. Look at that. Openings. Deduct. So let's go here. Oh, wait. I got to remember I didn't go all the way to the top, so linear is going to be off. Or look. Bam. Yep. Let's start over. I don't know if I did that on the other ones, but you see the point. Okay. Oh, I did that again. Okay, so we know what Stacy should have done. All right, and another thing we need to get. We know we've got roof drains. So we're gonna need the roof drain. We're gonna need the flashing for the roof drain and overflow drain, and then we're gonna need the perimeter for the parapet cap and flashing. Anywhere that window or wall meets roof, we need to consider we need some flashing. So if I would have done my roof like I did my openings, I would know how many linear feet this is, and I would not have to do this, but I'm doing it anyway. All right. So what we don't know really yet is about our walls. We did the measurements, but we got building sections. Okay, so we're going to go here, right? Because 3 over A 413 is probably going to tell me the makeup of my wall. 3, 4, 13. 3. Yeah, see, here are all of our walls. So for our framer, what are we doing here? Okay, that's the foundation. So we'll do all of that from foundation. Rough carpentry, that's a 6-inch bottom plate, or 2 of them. Well, you can always measure and make sure. That might be a little. Oh, that's about the same. Is that the same? We'll look on the foundation, but we know that storefront, height, tube, wood stud walls with that insulation, vapor barrier on inside face of wall, refer to structural for stud spacing. Structural for stud spacing? Okay. EIFS system over waterproofing over exterior sheathing. Alright, so we got that. We have all the measurements to do all of that. And then all of the window, we have to measure maybe the length of the windows for our bottom plates, for our window top plates, for our wall, whatever you want to call it. And then this is on our structural, any headers, everything above the window is the structural member, it's the header. Below the window, it's from the framing, kind of rule of thumb, but kind of not. And we know that the insulation is going to go only to the top of the building. We don't need to insulate the parapet wall unless it was a second floor, right? We only insulate where the humans are. All right, so, and this is interesting right here. Whatever that is, that's a lot of little things. So we could look at, right? Call out 5 over A 421. Let's do that because if when we do the actual takeoff, we need all of this and be able to determine how many linear feet. So how do we go from the takeoff, right? This is just a section view, but when we're at the floor plan, oh my God, I'm so glad. Almost thought I didn't turn the mic on. Thank you. All right, so when we're at the floor plan, right? So we have to measure if we have a detail call out, say for instance, like this one. Well, this is referencing because we know where the section view is. We know it's only in reference to this opening in the door. We know that this is only referencing this because it is within the call out. And so if whatever I see at 2 over a 413 to do the takeoff, well, I'm going to measure how many linear feet from here to here. Let's say 6.5 feet. And so I'm going to go to 2 over 413. Next one, 2 over 413. So if I go to 2 over, where is it? Right here. And so I know that that was 6.5 feet. That section view was 6.5 feet. And so I know that I need 6.5 feet of this, 6.5 feet or whatever that is, 6.5 feet of this one, this one, this one, this one, and whatever this is. 6.5 feet times the length of that is what I need, because every section view, right, is broken down. And so when we look at the exterior walls are all 4 over a 401. So whatever I see at 4 over a 401, I mean pretty much all of the exterior walls are this construction. So I go to 4 over a 401. I go to 4 over a 401. 401. 4, right? Where is it? It's up here. Okay, I go to 4 over a 401, but then again, I'm the framer. This doesn't tell me anything about my framing. So I'm like, oh, okay, here we go. Because I'm the framer, it's got to tell me more specifically about my framing. I can use this like I did before to determine how many linear feet. This doesn't tell me the wall framing, the drywall, the insulation. But if I go to the call out, if I go to 1 over a 413, now I get more specifics. 1. Now I know how my wall is built because there's going to be some arrows hopefully pointing to my wall. And I know all my exterior walls are the same. So if my arrow's not pointing here, then my arrow's going to be pointing somewhere else and I'll know it's the same wall. What's the and it says, oh yeah, look at the structural for the type. All right, so we go to the structural. That's the roof framing. Okay, roof framing is structural because the roof is a structural member. So the roof framing, not the roof finish, is structural. And so we'll look at this. We'll see what this is when we get there. It might be this afternoon's presentation. Girder truss. Let's see what we got. Oh, prefabricated truss by others is this. Now that's what I like. Is when I have a set of plans that show these things. Okay, so it only applies to structural framing. And so when you have these little things, that circle and that arrow, that tells the framer that only within here, only this part is whatever this is. So now we have it again, right? From this all the way to here, and then again to here. It looks like it's continued because it's not giving us any description. Yeah, so it's all the way through. So it goes from here to here, and then it connects here, all the way through here, and then again, just like that end, it tells you a different type of truss. And so what that means is from here to here, where one arrow begins and the other arrow ends, you got to look and find where they're trying to tell you about the trusses. And that would be, maybe they're breaking it up. No, yeah, they're breaking it up. We got arrows. There we do. There we do. Okay, so here we go. Let's start again. Because like I said, never look at this until I look at this with you. All right, so from arrow to arrow, we have this type of truss. One or two ply prefab trusses by others at the 32s. Okay. And then we go from, we have a new arrow, this arrow, to this arrow, and we look for the description. There we go. One or two ply prefab. Da 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 da. Then we got another set of arrows from here to here, and we look for the description. So when it comes to trusses, if they're putting them every 32 inches, then if you want to know how many you need, then you have to go 32 inch. Oh, wait. Feet? No, heck no. What's wrong with me? 32 inch, one. 32 inch, another one. 32 inch, another one. Da 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 da, all the way through. Okay, so if you want to know how many, because you can't. I mean, I guess you can. I guess you can. You could do it just like you do. Oh, you could do it the same way. How many linear feet? Turn it into inches, divide by 32. Either way, the first way is so much more nerdy and special. All right, so we always going to look for our headers, right? So this is a metal header, H hollow structural steel, and the dimensions. Okay, and usually with fabricated metals, the last digit on like W 84 by 115. The 115 tells you how many pounds per linear foot that can hold. And so if you know how many linear feet of that type of truss, then you know you can determine how many pounds, and they're determined price by the pound. So I rarely get those these days. All right, so we were looking here to see what kind of framing we got there. All right, here we go. Trusses, hold down, number 2s, wall, number 6. Oh, look at that. Tells you how many linear feet. That's nice. All right, so let's see. Our walls are, we already know they're 6-inch walls, and we know that they're wood framing, so it's not really difficult to determine what we got here. All right, so our posts, all right, and our columns are hollow structural steel. Then we look at 9 over S200 to see the makeup, and that's prefabricated, I'm sure. No, we got a couple of wood posts. That's nice. Okay, and so we do our framing takeoff for the structural framing. Our posts, what, are 15, 16 foot? So we just assume they're 16-foot posts with all this extra stuff to hold them down, embed them within the concrete. Slab on grade. We'll do that. That's easy. 6-inch concrete foundation wall with number 4s at the 16th vertical and horizontal. That's nice. So number 4 Goes this way and that way. So you do it the same way. The number fours are what, at the 16? Yeah, every 16 inches. So how many linear feet multiplied by inches, right? So you change that into locations, multi times however many locations, and then the length. That's for the ones that go in that direction. And then you do the same thing for the ones that go in that direction. For the how many linear feet of feet? How many linear feet of number four? All right. What else? Because our whole purpose is to do this for the final cleaner. So they have to clean, wash down the walls. They're going to have to probably polish the slab on grade or wipe it down or buff it or whatever. So we're going to measure how many square feet for our concrete person too of slab on grade. And we'll look at the foundation section views for the footer, the stem wall, all that stuff. All right, but for now, we're going to say slab on grade. And we know it's 4 inches. So it's the whole kit and caboodle. How old are you? Old enough to know all my construction principles. All right. And see, now I'm going to go all the way to the top so I'll know my footer minus that piece because I didn't go up in there. I have 211 linear feet all the way around plus what is this linear feet? How do we read this, boys and girls? From hash mark, there is one, not one, but from here to there, the number in between is an extra 9 feet, 4.5 inches. So that's our foundation. Almost 23, right? 100 square feet. All right, so let's get rid of that real quick. Cut off the light bulb. All right, so if I'm doing, so my final cleaner's got to buff out 2,300 square feet of concrete. And let's go look at some foundation section views. That's our main wall there, structural, external wall there, and we know any walls that are connected to the footer, the concrete footer is going to be a structural wall. So that is a structural wall if we have framing connected to it and bolted into it. And then we could look at section view 10 over S201 for the configuration of all of that. So you got a lot of section views here and a lot of call outs. So the concrete person knows basically how to form the concrete and more importantly how to place the reinforcing steel. Okay, so let's look at 7 and 6 over S200. S200, 7 and 6. Oh, look at the beautiful stem wall there we've got. So per plan, I think our plan told us. I don't know. Per plan. It told us. Okay, so we've got from here. It's a 6 inch, I think. So this would be a foot stem wall. So I know my stem wall is a foot by 412. Right? So I know how many square feet of concrete. But then concrete is in cubic yards. Right? So how do I do that? Well, I always turn cubic feet into cubic yards by dividing by 27. Remember, with concrete, you have 3 dimensions. You have the length of the wall, which was 411 feet. You have the width of whatever it is, 1 foot, 6 inches, whatever. And then you have the height, which is 6 inches. So that's 3. Multiply those 3 together, then you shall have cubic feet. And then divide that by 27. That gives you cubic yards. So now, if I know my my plate. I got a single bottom plate, stud wall, and sheathing per plan. We've got some shear walls, right? We got it when they talk about that. We've got also the waterproofing, okay, exterior footing, all the different section views for all the different concrete configurations. That's a stem wall at stud wall with 12-inch foundation wall. That's nice. Reinforcement per plan. I don't know what plan they're talking about because this is the plan. So I don't know. We don't want to spend a lot on our stuff here. We just do that and let the pros figure it out. All right, shear walls. Here we've got our steel. God, I can't even think. I just said it. Our structural steel headers, post beams, plans. So we don't have a construction defect. Okay, so this is typical base plate, concrete wall connection, HSS column. Okay, so 2 times da 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 with hex nuts, just 2. It don't say per side. Da, 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 okay. All right, so we don't mess up and the thing don't fall, right? It don't fall. There we go. Isn't that pretty? All right, so you know what you're doing when you can look at your detail views. You got to be able to get down to your detail views and do the math. Okay? Very, very important. Stem wall or continuous footer, stem wall, and we got the hooks here, and then we also have individuals running the whole perimeter, right? This is a section view, so we cut it and then we broke it apart, and this is what the interior construction. So this is what we use for our detailed material quantities. You got to be able to look at the detail views and determine your material quantity. So I've done that. So my foundation, I want to do my foundation. See, those are my 2x6s. And then, see, I have different continuous footers. See, so when you do your takeoff, let's just do that. Did we already? Yeah, we did, because we did. See, when you do your continuous footer, you want to make sure you break up your sections, because you want to go back and look at each of these, because what? The continuous footer is going to be different. The stem wall is going to be different, thicker, smaller, whatever. And then what we got here? Look at that. So we have a 4-inch slab on grade outside the building with Okay. And here too. So that's the additional concrete work. And then okay, so let's look at that. 9 over S201. 201. 9. All right. Okay, so yeah, that's slab on grade. So what do we do in this case? So you have this is almost like, this is kind of different because it's not like this. It's not as clear when you want to determine how many square foot, when you want to do actual, like how much. So with me, here's real clear. This is about, what, 6 inches. This goes from 6 inches to 12 inches. I'm going with 12 inches. Sorry, I'm just going with 12 inches stem wall because I'd rather have more than not enough, right? So to do the takeoff for this, you have this stem wall, this continuous footer, this stem wall, and then the flat portion slab on grade. And then, yeah, you're going to do dowels to match the slab reinforcement at the 24s. I mean, 24s, that's 2 feet. This thing isn't even 2 feet long, so it's probably at both ends of it. This one right here at the 24s. And this is a continuous, right? So it goes all the way through the slab. And this goes all, these two go all the way through the slab. And so however long the slab is, right? Let's go back. Where were we? I don't know. So yeah. So however long the slab is, that's how long that continuous is. Which is this. I like that. So when you can go from what? Plan view to section view. And the section view will take you to detail view. You'll make sure you have a good thing. All right. So we're going to take a break and see what else we got. Remember, this is a shell, so we don't have any. This is all the MP we got. Mechanical plumbing plan. We just have stuff when it's a shell. We only have things that are coming into the building. So even the electrical plan, right? Just coming into the building. No lights, no nothing. Just the panel. Even I don't even see that we have the panel. I don't even see the panel. It's like just put the lights in. There's no panel. Let's see, the junction box, lights, yeah, we just putting everything in. So when there is, unless we have to provide temporary power, of course we will. To make sure this works, because it's just like junction boxes for the drive-through. What's one? Yeah, civil set. Yeah, we were looking at that. Civil set, site demo, civil set, utility plan. So that would be our power coming through. Water. Where's power? Water. Let's just look on the list. We're looking for transformer. I'm not really looking. Now I'm going to look. Sewer, grease, trash, existing, cap, this, that, and something else. No? Do we have a electrical site plan? Other than, okay, no. So we just, panel A. It's just right there in the middle of nowhere. That's beautiful. Okay. So yeah, we'd have to get more details. Oh, there we go. Yeah, so yeah, shell, of course. We just had it floating out in the middle of nowhere, but it's gonna be somewhere, and we have to look on the. I'm sure it's shown on the utility plan. We'll find it for the lunchtime presentation. See, so shells are nice. And again, let's go back. There's a whole bunch of stuff. This is a shell for a Chipotle. See, it doesn't even say, but yeah. This is a shell for a Chipotle. That's going right there. Next to it, I think that's a hotel. That's coming up later. So, yeah. We've got everything the civil set. Yep, 23. Right, that's what in the pickup window. And then we're going to do site demo this afternoon. We've got some site demo. We knock out some trees. And that's always nice. And we're going to stripe the parking lot. Yep, it's going to be beautiful. And we got some concrete, site concrete now, other than the foundation, right? So the site concrete is going to be on the civil set. Grading plan, I'm not messing with a grading plan unless it has the section view of the earth, and it does not. So when they send me that and ask me to do the grading estimate, nope, unless it has properly been section viewed so you can see what the existing elevation is in comparison to the one they want. And that's the only way I can do it. Now, they'll sell you a $1 zillion program that'll take all of this and claim they're doing it, but nope. I'm good. Erosion plan, what's that? All of those fences, all that stuff. That's not really fun. But what is fun is the utility plan. So we'll do all of that later this afternoon. But right now, we are going to make sure we have everything for our framer and our final cleaner. Oh, you know what? For our final cleaner, I'm sure they're going to have to. I don't think they'll have to wipe down the exterior. Other than, oh, look, we left out windows. That's why you don't. Come on. That's why you don't do the estimate in one day, boys and girls. Because it's not due till Wednesday, I don't think. All right. And so the framer has what they need. And all of this, this is that parapet wall. I'm assuming that I did get the roofer. Let's see. Fix what the roofer needs. Let's get the roofer valley flashing. That's always fun. And we don't care about spelling. And we want, and then sometimes we have to have this insulation like doubled and tripled over. Because right, valleys are lead us to water flows from the valley. Might be some parapet walls. I mean, some crickets in here, but it doesn't really say specifically. And that is another opening for our roof latch, roof thingy, so we can get on the roof. And that's where our ladder is on the other side. All right, so the roof is good. And what's 8? Let's see what 8 is. Canopy. Okay, we don't care about that. We're not going to install that. They have a vendor. All right, so we have our floor plan. And let's go to, because we got our walls. Let's see. We got the roofing membrane. So not only do we have it that the 23 square feet, we've got to have the roofing membrane up the parapet wall too. So that's an extra. Let's scale that. 3/4 equals 1. Sometimes this stuff be off, but we'll try it. So the parapet wall needs to be in it. Oh, we did say it was 8.5 feet, right? Well, no, not the parapet wall, not the no. Let's see. And if you had questions, you couldn't ask me because I'm not paying attention. But next time we'll make sure we do. Let's see. Dimension. Because we want the additional, and we'll add that too. Because it's got it, they say go up and over, right? And that's the insulation. So it's going on top of the insulation. So we can stop right there. Extra 5 feet. So extra 5 feet times 400 and what, 11? So that's a lot of extra TPO that you don't want to mess up or forget about. All right. I think we got it. I think everything. Insulation, we're going to go up the, let's just do this. Insulation. 14 feet. Say 14 and a half feet times 411. Right? That's the perimeter of the building. So we got pretty much everybody's takeoff. Just have to do more in terms of the foundation. Or let's go, where are those shear walls? That was annoying the way that they did this. That was annoying. Let's see. Where's foundation? Where is it at? Okay, no. Another thing, framer needs to know all of our doors, so we only have 3. And then the storefront, that frame really questionable. The aluminum storefronts, usually the framer doesn't provide anything but the hollow metal one, so, that's another question. But if it's only the hollow metal, then it is one that is 3 feet 6 inches high, wide by 7 feet high, easy hollow metal, and only has to install that. And the storefront person most likely would install the storefront. All right, so we're going to take a quick break until 11 a.m. to let it all sink in. We'll be right back. dokie. We're going to get started again. We had to take a little longer break there. All right, so this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now, this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing, so we won't break down the individual pieces of, say, like the foundation until we're ready to win and do the work and get an actual pricing. Foundation assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect. Let's see what we're removing. All right. So 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree, that's how they base, either putting it in or taking it out. Okay, so that's important to know. And if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side, this is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is really attached to something, just like maybe this is. I don't know. But what's the scale? On these plans, scales in a funny place. Here we go. 1 inch. Oops, cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. In the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced because that's how we price it. It's priced different if it's reinforced. So we're going to go like this. Let me go down. There we go. Come on, don't fail me. One and two, one and two. Yeah. Okay, so there's a lot of protect. So we just going with what we see remove and see that's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. Alright. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Evaluate and sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Given to. Not our problem. Protect. Now the protect part we can do some protect. Go into the specifications on how they mean protect. And we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. Alright, let's go back. Let's get this one. Alright, so, what did we say that was? The panels are 16, 17 is curb and gutter. Okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. Then we'll just 17. Alright, and panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. If those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. Let's see, 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. Where's a separate one? I guess you just gotta go out there and see if you find some boulders because they're not marked. So wherever the boulders are, get rid of them. That's extra. So all those are things to note, but nothing to really, be able to determine because they're not shown or anything. So that's like removing a tree, depending on the size. two. That's that one. All right, so we go all the way down. The striping plan, really, we just now they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a three to 5 foot sidewalk. So let's see. We're going to do it both ways this afternoon when we come back together. So we are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right. So scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 inch. I mean 6 foot, not even 6 foot. I go by 6 feet because it's closer. Or, but then you got to make sure they're all 6 feet. See, that's 6 feet. D, D. Now that don't look 6 feet. See, that's 5 feet. 6 feet. What's that? Is that a special? That's a special kind. That's a curve right there. So, can we use all 6 feet, or just measure how many linear feet? You know what? I'm gonna use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk instead of doing it by the square foot, because that's we're gonna do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're gonna just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's the patio area. I'm gonna make that different. And do we do all D though? Mm-hmm. Yeah. All right. So that's the sidewalk. And then C was parking pavement. We're gonna do that by square foot. We'll call that parking. And then we'll go by cost book wise what it tells us. So we're just gonna include all of that, because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Ooh. Ooh. Going to nilly willy. Okay, let's just cut it off halfway right here. Cut it. Because I like to be as precise as possible. Alright, let's cut it off right here. And you know what? Yeah, we got a lot of this and the small little curve. Let's go. Let me just go. We're gonna add that. very like surgery. Forgot I'm recording. I'm like, hey, it's still quiet. Except for the clicks. All right, there we go. See, let's see. Yeah, then we gotta come through and do the more annoying curves because we're a little bit. Ooh, look at me. Look at me. All right, see. All right, so striping plan. Why don't you call it the concrete plan? The heck? See, they broke it up in phases, but we don't care. Let's hope we're not asked. All right, we got some arrows, so we do those separately. But in the meantime, what is B? Sidewalk. No. Did I say what? I said B. Drive aisle pavement. 5 inches. Then 9.5. 9.5. Da da da. We'll look at the specifications, but I mean, we could go on, right? And what's G? We'll do G. Let's just know what it is. We got 5 minutes for this session. Oh, good. No. Landscape. That's good. That's where the flowers are going. Flowers, flowers. What's M? Bike racks. That's nice. Let's see. It's going to be flowers. Okay. Because that's still in this area and not in this area that we didn't include in the sidewalk. And you see right here, it's a little thicker right there. So we're going to say that's probably let's see. We don't have to guess. Well, what's this one? 4 inch. Okay, well that's the smaller one. So let's delete that one because we said they were all inch feet, not inches. So let's do this. This is still our 6 foot concrete up until we get to there. Then it's a 4 foot. 4 foot sidewalk. From here, right there. Let's go over a little bit. From there to okay, and then yeah, we'll fill all that in while you're gone. And then A, we'll fill that in while you're gone. And then G's the landscape is A. Oh, good, existing. We don't need to fill that in. And so that should also mean we're not striping that. Let's see. Yeah, no. We're going to say we're not because it's existing. So we are going to always exclude existing striping. All right. Stop. All right. So that is the Monday live edition of What the Heck is Stacy Doing? All right. So this is our shell. Right. So when we come back, we're going to complete the little pieces of the takeoff we didn't do, and more importantly, the pricing. So if you have any questions between now and 2 p.m. Pacific time, make sure to email me at education@sfjohnsonconsulting.com, and I'll see you this afternoon. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I have a little information I wanted to give to our small GCs and large DCs so they can get ready for 2023. There's a new class we were given. I'm not sure how old this is, but I think it's awesome. If you've ever been to a live construction site, it's a very dangerous situation going on there most of the time. And I could understand that because when everything is active, everything is moving, it's hard to be able to make sure all of the damage and the hazards are actively where they're supposed to, right? But it's really hard to do. And so without a plan, it's even more difficult. So OSHA has a class that we are going to be presenting. It's a 4-hour class, though, and we will present it in 1-hour segments, and it's called Design for Construction Safety. So again, basically, the architects, engineers, they build the set of plans for us to put everything together, but they don't really put into mind or have into mind in their design how we should stay safe, right? So they have pretty much no involvement in the actual construction project process, right? So what we're trying to do is give a course that gives a couple of course objectives, and one is to be able to identify the factors that contribute to construction industries and fatalities on site, right? General industry, right? We do things in a static, pretty much in one building. Things never change. We are just walking back and forth. But with construction, scopes of work change, equipment comes and goes. And of course, if you're in construction, you know what I'm talking about. And so this class helps the project managers, helps the construction people, helps the owner not be sued, because this is an active thing that we're doing here, and we're teaching you to identify the factors. We also explain and analyze how worksite hazards happen, okay? We discuss the hierarchy of controls for construction hazards, and that's very important. And then last but not least, we provide a methodology and with examples, okay? And design features to show you, again, to keep your site very safe. So if you go to our website, we have some information where you can sign up. This is a class. It is $4.99 per company. You can invite as many of your people as you like. So if you go to Safety Lane over here on the right side, the other left on the right, you're going to go down to Design for Construction Safety, enter here, and then you'll be taken there, and the objectives again, why it's needed, what we go over, methodology, kind of give some information what the class is all about. And if you choose to sign up, please do so here. You can choose your own day and time. So for instance, what we ask is you pick the same time. So the class is available from 10 a.m. to 2 p.m. Pacific time. And so pick the same time, but you can pick different days. And it's just first come, first serve. And we're trying to fill up that class and the OSHA class. Now, if you so choose to take this class, you will get OSHA 10 for free. Okay, so keep that in mind too, which you want to be all wrapped up for your safety for 2023. Okay, so if you have any questions, please email me at education@sfjohnsonconsulting.com. Stay safe and let us help you do so. Have a good rest of your week, and I hope to talk to you soon. Hey everyone, this is Stacy again, and we are still on the same project, our repair facility for crashes. Let's put it that way. And now we're looking at the plumbing plan. So because it's not a big, there's no really huge need for the plumbing aspect. So what we're seeing here is it's important. They're giving us a couple of call outs here and here, And then this is the piping that's running through the main building. And then we have some standalone eye wash stations. And then these call outs are actually right here. And so what's important is to make sure when you're doing the takeoff that you note the scale. So you can't use the same scale for this full set and then these separately because they are of different scales. So we can measure one scale or whatever, but when it comes to actually, recording the actual numbers, we need to make sure if we're recording the numbers for the upper that we have the scale set to 1/8. Okay, so now we have, these are accurate measurements. And for this, so this one's going to be a little tricky because they're both on the same page. This is 1/8, so you could double, or no, this is 1/4, so you can double that and use all of 1/4 scale, but I don't do that. What we have to do is do each one separately, and when we print it, just note that you have to print it differently for the different scales. And so because this is, remember, this is new construction, or this is existing, we have to note if we have in our plumbing plans, if the plumbing here is actually new, or are we replacing existing plumbing? Because if it is new, because this is the existing building, this is the new construction. So if we're just replacing, and that's why I say this, if we're just replacing sinks, water closets, and lavs, then we don't need to incorporate the rough-in costs. But if they're actually new, then yes, we do. So what we need to do is go back to, remind myself, and go back to the building demo plan. Let's turn off some of these colors. Right. Let's turn off. Yeah, no, there's no bathrooms. This is the demo. There are no bathrooms in here. Those are all new bathrooms because this is the existing building. And even with the color, you don't see bathrooms. So all of our plumbing, go back to the plumbing plan, just a quick reminder that no, it's all new. So yes, we'll have to incorporate all of the rough ends for each of the pieces of plumbing equipment. Okay, so all this SS, sanitary sewer, 2-inch, and then we go down here where we have water closets, urinals, lavs, floor drains. Okay, and then here we connect to the existing, and then the other bathroom, everything is new. So rough ends for everything. And so that is all of the horizontal measures, of piping. And then we have our two plans, right? In our plumbing plan, we have the sanitary system, so all the sanitary items, vents, sanitary. And then we have our clean water system with all of our new hot water, cold water, hot water return piping. Same thing here, all of the call outs. Hot water, cold water. Okay, so we run each one of those separately, all the horizontal measures. And then we also have gas that we're running to the paint booth and to the heaters, gas lines, and CO2. Now, With the CO2 lines, or the, not CO2, compressed air. With the compressed air, this symbol, it says, well, based on where the compressors are going to be. So for the purpose of the estimate, we just included the full measure, this full 1/2 inch piping for this, the full measure of the building. So the full measure of the building was 68. So pretty much 68 feet. So each one of these runs 68 times 1, 2, 3, 4, 5, 6, all the way. Okay, so that's how, we have to add that one. That's how those are run. So we would have a pretty good, and then the CO gonna go up, and then we have to account for all of the controls, but this isn't all the way complete yet, so we have to do that. So remember, all horizontal runs, and again for all of the compressed air piping, because we don't know where the compressors are going to be, we just, these measures are, we just make it the full 68 feet per location. Now the riser diagrams, the rule of thumb, what we do depending on the height of the building is usually 10 feet per vertical measure of pipe. And remember, these are the horizontal measures from the plans, and these are the vertical measures. So we have to count each one of those based on what it is. Vent, 2-inch vent, and this is the sanitary riser. Okay, and not complete because we got a 2-inch vent right here. So we kind of do them really early so we can look 1,000 times to make sure we have everything. And then that's that riser, and now we have the water riser. Vertical measures of the pipe that go up. 1/2 to the cold water, hot water, whatever. And these are the measures we see on the plan, so we don't have to worry about those. And that's the whole purpose of the riser, to show you the vertical measure of the pipe so you can get as accurate as possible for your takeoff. And here is the gas riser. And the only thing we have here really is 2-inch going up. Everything else is the vertical measure we see on the plans pretty much, except for a couple of locations. And where it comes into the building, you have to account for that connection. And then all the controls are here. And of course the different size. And that's going to be it for the power. Power. I wanted to say power. I don't know why, because that's coming up next. That's on my mind. For the plumbing plan. Okay, so if you have any questions, same thing, same email, education@sfjohnsonconsulting.com, and we will be back with the full estimate to see what a job like this costs and in comparison to all the others that we have to complete. And please give us your thoughts and make sure to subscribe. See you very soon. Hey everyone, this is Stacy with SF Johnson Consulting and Construction Services, and in this video we're going to discuss the basics of plumbing estimating and what we need to consider and what we need to look at if we're going to be an estimator that handles specifically plumbing, and what comes first, second, and third. Okay, so this is the cover sheet for the plumbing set, and it's going to give us all of our plumbing fixtures, everything that we're going to be installing, and it will give us the size of the hot water, cold water, and the sanitary pipe sizes and the vent size. And so that's important when it comes to your rough ends. And so we know that if we're going to install plumbing equipment for the very first time, we need to add to our estimate what's called the rough end cost. And that is the additional cost to install the hot water, cold water, and sanitary systems to that piece of plumbing equipment for the very first time. So you always have to consider that, well, in addition to your plumbing fixtures themselves. And so if you have a good cost book, it's going to give you the cost per type of fixture, and of course the man hour units that it's going to take you to install that. So please never forget that, and it's specific to only new construction. If you have a renovation, it doesn't apply. So if you're going to just take one water closet out and install it in another in a renovation, that would not apply. So roughing costs only apply to new construction. And so here are your fixtures, and then all your typical symbols. We're going to replace water heater, so this is a good idea of all the things that you're going to have to find the prices for. And as we know, just like for the electrical set, there are two plans. There's one for the sanitary system, a sanitary and vent system, and then there's another one for the water, gas, and whatever other systems that are appropriate to this type of building, and this what these people are doing inside the building. Because this is our set of auto repair shops. There is a for the plumbing set. We'll have a compressed air and a gas line as well. Okay, so this is the sanitary system. Of course, we have to have a good tool that was going to measure linear feet, because yeah, our piping is in linear feet. And so if you have a good cost book too, you don't have to really consider angles and reinforcements, because all of that is considered in the price. If you do the assembly price for plumbing for that type and size, it's going to include all of the supports, any angles that it assumes you need, supports you need, because based on industry standards, it has to be supported at certain lengths or whatever. And so if you have a good cost book, that'll help you eliminate having to do this and the small little things, especially if you bid a lot, right? And so always, when we bid a lot, we're going to use a cost book. We're going to use a very good digitized software to make our measurements. But if we win, right? If we win, then we go back and we do a very good detailed overview of what we've done to make sure that price is appropriate. If it's more than 30 days, you have to look at the material cost again to make sure it's the same and that kind of stuff. So, okay, so the plumbing plan, we take all of our linear measurements, and don't worry about the fixtures, because we're going to use this riser diagram to count all of our fixtures. Okay, so we use all the plans to measure our linears. So that's sanitary and vent, and then the other plan is for all of the cold water, hot water, piping. Okay, running to the same fixtures, of course. And so we just have to have a good tool to measure linear. And then this one has gas line. And so, same thing, just linears and compressed air. Now, when you have something like this is a 1/2 inch compressed air line. And for this one, they wanted us to use black steel. So, and then a control, but this indicates we don't know where the end of the line's going to be. And so in that case, you have to give them something. And so what I did is just give them to the end of the building. It's got to be somewhere within the building. At least you give a good allowance, and then you let them know that as well. Okay. And so now the riser diagrams. You use the riser diagrams to determine the vertical measure of pipe, because pipes go up and down, right? And your plan only shows you the horizontal measures of the pipe. But at certain location, the pipes are going up and down. And so that's what the riser diagram helps you determine the size and going up. So rule of thumb I always use is typically 10 feet per going up. So 10 feet, 10 feet, 10 feet, 10, you know what I'm saying? So, that's how you determine it, and that's why I put a dot on each one. So 2-inch vent, and every time I see that, okay, so I know I've added 20 of them. Well, I know that's 200 feet of 2-inch vent vertically. And if you have a good cost book, it will give you a different cost for a horizontal assembly price as opposed to a vertical assembly price. So you want to look out for that too. But the other thing is you can use the riser diagrams to count all of your plumbing equipment and be very accurate, as opposed to I always like using it from the riser diagram. And remember, you're going to have different risers. So you have a gas riser, you have a sanitary riser. It's typically going to be the same things that you're counting, so you don't have to count it twice. But look on in the water plan, like if there's a water heater, that's not really sanitary, so it wouldn't be on the sanitary riser, it would be more on the water riser. So things like that you need to look out for. Or if it's an oil interceptor, which is a sanitary system type thing, it would only be on the sanitary riser and not on the water riser. So those are kind of little things you need to look out for. But other than that, you could just use one of the risers to do all of your equipment, your plumbing equipment counts, and all of your venter roofs. Okay, so shoot. And then there's a gas riser. And see, all of these measures are on your plan. The horizontal measures are all on the plan, so you don't have to measure that. Riser diagrams are just to show you where the vertical measure up and down is. So when you put your estimate together, this is basically what we do. And of course, we love detail. So all of the horizontal work, and it says PVC, but it's not. I mean, sanitary is PVC. The water is copper. Okay, so that's all the horizontal measures of pipe and how many linear feet. And then this is the vertical measure of pipe and how many linear feet. And then, of course, all of the fixtures, right? The cost, and then the rough ends that apply. And then, of course, we're always going to add a cost to connect the existing waste, vent, water to the new service. And then the vent to roofs, and then all that little stuff. And you want to check your specifications because you most likely have to have insulation for the pipe. Okay? And testing the system, especially with plumbing. Okay, so you want to break it down in very good detail. Okay, if you'd like to take a class with us, let us know. We'd love to show you how to do. And basically, what we do is start with very simple projects and then work our way up to hotels. So you know what to do in each event and how to determine, again, just each of the measures, how to determine up and down the walls, and the rough end cost. Those are things that are important that you have to make sure you include. That's not necessarily on the plans, right? So you know you have to include that, and then testing and flushing the system. So if you have any questions, please let me know at education@sfjohnsonconsulting.com. Let me know what you think of the video, and please keep your eye out for the next one. Talk to you soon.
Hello, everyone, and thank you for joining me. My name is Stacy Johnson, the owner and operator of SF Johnson Consulting and Construction Services. And then in this snippet, this is part of a multi-series class where we go through a set of construction documents, the architectural set, structural set, the civil set, and all the MEPs. And we go over them sheet by sheet for what's important, what you should be aware of, and basically what we're looking at. And in this snippet, we're going to be talking about the MEP site plan. Okay, and this is, we call it the MEP site plan because it is not a full site plan. It is a site plan that gives you kind of like a salad bowl of what is in a full set, a full civil set. The site plan is just one of the sets that is comprised within the civil set. And so this is like I said, it's a compilation of all of the trades just on one sheet. It's not used for detail, of course, because we need all of the individual sheets that would be comprised within a civil set. So this set or this sheet gives you contour lines, right, which would be found on the excavation page of a civil set. It's going to show us the parking lot striping and curbs and gutters, which would be found on the concrete asphalt plan in a civil set. Okay, so this is just one sheet that gives us kind of a little bit of everything that we would find in a full civil set. And then we're going to just go over each thing individually and give you an idea of what we're looking at. And so the first thing we'll start off with are these lines that look like mountains. And those are called contour lines. And those are the lines that kind of I always say kind of, that do represent the GPS coordinates if we were to go out there and do a survey. Well, that's what they mark each of the contour lines, and it basically represents the height and the depths of the land or the dirt at various locations. And so what we're looking at on this MEP site plan are just a few of the contour lines. And what I want to go over is just how they represent, because the contour lines, again, represent what we would find on the excavation plan. And on the excavation plan, what is that? That's telling us how much dirt we need to either cut or fill in order to properly level the land to build, in this case, our restaurant. So the way they represent the contour lines of what they found on the survey, when they did the survey, the number that represents the number that, or basically before number, would be the number they represent here in the parentheses. Now, 588, we don't care what that means, but, we just want to make sure you know that before and after, right? Excavation, what we found before, and then what we need to either cut or fill to build our property or build or level it out for our foundations, our parking lots, and all of that good stuff. So the way they represent before is in a parentheses, and the way they show what we want as a result of the excavation is represented in a square. So this is for this particular architect and what they use to represent before and after, but it'll similarly be represented in some kind of way. Or we can see that before is represented by the broken lines, the broken lines, and where after is represented by the solid line. Okay, so in this MEP site plan, they're representing the heights and the depths of the dirt at various locations. Before is the broken line with the parentheses. What they want after they've done the excavation is represented by the square and the solid lines. Okay, so that's one thing for our MEP site plan. Another thing is underground utilities and how they represent underground utilities. Well, underground utilities are represented by, if they're existing, they're more of a gray color. And so we see here UT, so that tells me that's an underground telephone. They have G, it should be underground gas, but there's a lot of inconsistencies in this set. And then we see underground EUE, underground electrical. And so how do they represent utilities that are underground and that are existing? They represent those by a gray broken line. Usually, new construction is always represented by a black line, meaning this is the new construction as opposed to the existing. So if I had to look at this and say in words, we see that the SD, which stands for the storm drain, is black, where all of these other ones are more gray. So that would tell me maybe we have a new storm drain coming through the new construction that is junctioned or broken off from the existing storm drain, something like that. Okay, so underground utilities are represented by gray lines if they are existing and broken gray lines. So you just have to kind of look what's the existing, what's the new, and kind of determine it that way. And so if we look all around this set, we'll see that we have, now this is a black S. So even though the line is gray, the line is probably telling me it's underground, yes, but the black is telling me it's a new storm drain or sewer drain that's coming into the building right here. So underground utilities, again, if they're already existing, broken lines, gray color if they're new, more solid lines, or maybe a broken line, but a darker representation of what it is. And so here we see that there is and we know that these are new because, again, this is new construction. So we have 8-inch water, then we have the underground electrical, underground telephone, underground something else right there, 4-inch gas. Okay, so broken lines tells me it's all underground utilities, and they're all coming into the new construction. Okay, that's another thing for our site plan that's typical of a site plan. One thing we always have to make sure we do correctly is to make sure if we're using a digitized software that the set of construction documents or the plans are to scale. Okay, so what does that mean? That means if we were to print a full legitimate set of construction documents and we used a regular ruler for every inch that we measured with that ruler, it would really mean that we are measuring 20 actual feet in real life. Okay, so you always want to make sure if you're using a digitized software that you confirm that the scale of the set that you receive is correct. And so here on our digitized software, we just tell it that for every 1 inch, it's 20 feet. We set the scale, and then we take a measurement somewhere on that set to confirm that between 20 and 40 should be 20 feet. So we know that this set is to scale. So when we do our measurements, we know that our measurements are correct. All right. On any set of construction documents, you're always going to have keynotes. And how the architect represents the keynotes is really based by architect to architect. But it's very important that you look at each of the keynotes individually, match them up with the keynotes that are on the page, so you can make sure that you covered everything on your set in terms of your full scope of work. Every set's going to have keynotes. It's important that you find a methodical way to make sure that you have covered every one of the keynotes and what you need to do. Okay, so let's go back. This is a very generic MEP site plan. It shows us some of the things that would be on the site plan all on one sheet. Remember that the civil set, sorry about that. The civil set is the set of construction documents that show us everything, all new construction outside. Okay, so when you walk outside any door of the office or home, what you're looking at is everything that you would find on a civil set if it was to be built new. What do we see? We see asphalt concrete. That would be a separate plan. We see, we see the results of underground utilities, right? We would see fire hydrants or something like that, or manhole covers or something like that. Well, that would mean that there are underground utilities under our feet. We would see trees, right? That's part of the landscape plan. That would be a part of our civil set. We see, again, in this Popeyes, we would see parking lot striping, handicap symbols for parking lots. We would see all of that. Again, all part of that same asphalt concrete striping plan that we would find in a full civil set. What they did here was give a little bit of underground utilities, a little bit of excavation, some parking lot striping, asphalt concrete, all of that on one sheet. Okay, so this is kind of like a salad sheet of what would be comprised individually in a civil set. Let's see what else. Scales, always important. Make sure you are always on the right scale when you're doing measurements, or else your measurements are not valid. And the only reason why we had to have a set of construction documents is that we can look at them, we can scale them, we can make measurements, and from those measurements we can apply value to this is how many linear feet of new wall, this is how many cubic yards of concrete, and we can give a cost to how much it is to build this thing. Okay, so again, an overview. Underground utilities are represented by broken lines. If they are new utilities, you'll see black. If they are existing, you see gray. The contour lines are represented by the heights and depths of the dirt. Those are the contour lines when we go out there and do the survey. And it's showing us for the excavation plan what the height and depth of dirt is at certain locations, and then what we need to do to get it to the height and depth that we need it to be at, so we can build our storm drain basins and build our new foundations. Okay, so that's what we're seeing here. Make sure you read all the keynotes regardless of the sheet. And one thing, and we'll go over individually, we are looking at this sheet from a plan view. And you will look at any of the sheets from one of 4 different views. You'll look at the sheet from a plan view, which is the view from above, and we'll have a separate class detailing each of the 4 views, how we look at it, how we flow from one to the other. But on this sheet in particular, we're looking at anytime you see the plan. See, we always say, send me the set of plans or whatever, but really that's a misnomer, right? Because plan is a particular way that you're looking at the project. It's a perspective of the sheet from which you're looking at the project. The plan view is the view from above. It's as if you're hovering over, you're flying over, and that is the most basic of the views, is the plan view. Okay, so from the plan view, we get a good idea of the site plan. But if we were to, say, build the walls of the Popeyes, the plan view doesn't tell us the height of the walls. It doesn't even tell us the thickness of the walls. So we need other views, other sheets in order to give us more detail. All right, so this is the MEP site plan for our set that we are breaking apart and analyzing. And remember, if you have any questions or concerns, you can always go to our website, www.S as in Sam, F as in Frank, johnsonconsulting.com. Fill out our online office hours. We will make time at your convenience to go over anything with you to make sure you understand. Thank you very much for joining me this time, and please make sure to return. You're awesome, and well, I guess that's it. Have a wonderful rest of your day.
But I'm so frustrated. Hello to my loneliness.
Thursdays, we work on the underground utilities and grading. And so that's what we'll be doing today. That's what we'll be doing right now. So, what are we looking at? We are looking at the site plan. Site plan will show us all of the concrete. We need our utility plan. All right, so yeah, testing 1 2 3. And please, if you'd like to say something, I'll try to answer. Okay, so again, we'll be live again today at noon, going over a Victoria's Secret from top to bottom too. But this is just our little live presentation that we want to go over stuff, and it's really just to test to see if I know what I'm doing. So we are live, and been live for about 40 minutes. So we had some minor hiccups, and I should have went unlive, but I didn't want to do that. I wanted you guys to know that I was here. So now, underground utilities. What are we talking about? We're talking about all of the underground sewer. So SS, sanitary sewer, we have an 8-inch pipe. All of the water systems. Here we have a 2-inch domestic water system. We have a 10-inch fire, the piping for fire. And see here, it gives you the links, but I never go by that. That's why you want to always have a good digitized software to do your measurements. And so when we are looking at underground utilities, we're just measuring the lengths of the pipes, basically. And so we identify each type. Now you will have angles, and it gives you this angle, and then you got to go and count those out. And so we always go by our keynotes, and our keynotes are going to give us direction on what to do. And so when we're performing the takeoff for the underground utility, we're just looking for all of the different utilities. Really not very difficult, to do. You just need, again, a good digitized software, so you are doing your actual measurements. So for the beginning, you're going to always review your keynotes. And so what I normally do is just print these out, so I'll have them in front of me. And then really this just talks about all the gate valves and the sizes, and all of the elbows and the diameters, 4-inch 90 degrees, 2-inch 90 degrees, 4-inch 4x2 reducer. Okay, so all of those things you want to make sure you account for. So remember, when we talk about underground utilities, we're talking about all of the pipe, all of the sewer work, water, and the electrical you won't find on here. It looks like we're having some streaming issues, but we'll get that corrected. Just give me if you are able to see this at a later time, just let me know what you think and what the quality of this was, and then hopefully we'll have it all fixed by 12 o'clock. All right, And so, what you want to always do is just, again, the digitized uh, measuring is important. Now, when we talk about the underground utilities, you'll notice that there's nothing here that shows us anything about the electrical. Okay, and that's not by mistake, that's not typos or whatever, because in our electrical set, it's its own set, and it will have all of its own site work basically, and that's what the utility plan for the electrical set is, the site plan in the e set. And so, yeah, you won't see any of the electrical. It may note it, like here it notes we have lights, and it'll tell us that, where does it say? It says we have the lights just for reference. They're not for the electrician to do the takeoff. Because as you see, it's just a symbol. It gives you no details about what it is. It's not marked. And so anytime you are on a set of any set and you see a symbol and it doesn't describe what it is, there's no mark, there's no tag, that's a clue to you that it's tagged, it's marked, it's noted in another set. So yeah, so we will talk more in detail about. We'll have one of these every Thursday, a different set, and right now we're just going over the details of what we look for. Real simple. Now, one thing you will have also on your plan when we talk about the underground utilities, we have the thrust blocks. Let's see. Here we go. Right here. Here's one. Perfect. Okay, so this is the only thing that's a little difficult. Uh, is trying to determine the value of the thrust block. And what are thrust blocks? Well, when the liquid or whatever, or even when the earth moves, it's going to move the pipes. And so we put the thrust blocks in certain locations. They have to be certain sizes at angles where the pipe is at an angle. Okay, so when it comes to site utilities, that's like the only thing that's kind of a pain in the behind is, okay, concrete. So it gives you a little about, what it should be, age, but then, you have to determine that in terms of cubic yards of concrete for each thrust block. And so there's maybe a lot of guesswork into that, but if you know how to, if you know the three dimensions, then you can determine the cubic area or cubic feet, and from that you should be able to turn that total into cubic yards of concrete. Okay, so that's the only other thing for a utility plan that's kind of funky, is everywhere you see an angle, even when the pipes come to an angle, you have to have a thrust block. And the size of the thrust block depends on what we just looked at. Okay, and another thing you don't consider on underground utilities when you are just doing the utility plan, although the contractor also will do the excavation. Okay, and so you can just, you have to look at the details again. How far below the earth are we running the pipes? Okay, and that's another thing to, and when you're talking about the excavation, is basically trenches, right, of a certain length, but then they have to be a width and they have to be a depth. And so, a good rule of thumb is a foot on either side of the pipe. So you include the pipe width and then a foot on either side of the pipe. And if there are no details, which I doubt there wouldn't be in a detailed set of plans, but there will be details on how deep the pipe has to run, and if they cross each other, if a sanitary pipe crosses the water pipe, then one's got to be above the other. And then now we're talking not, and the typical, from ground is typically, if you gave it a 2-foot trench depth, you'd be fine for underground utilities. Unless, you got places where there's 4 or 5 of the utilities running and crossing each other, then no. So something like this, if this is, and remember, a set of construction documents is the graphical representation of the project. And so when we look at this, we're supposed to be looking at real life, how we're really supposed to run it when we get out there in the dirt and we cut the dirt and we run the pipe. Okay, so that's why we scale it. That's why the building envelope is going to be exactly the pretty much the area of the roof, right? So when we run these things, I mean, it looks like we're running a 10-inch fire alongside 2-foot water. So those. I mean, we may just, if we want to be real accurate, and a good estimator is going to try to be as accurate as possible. So if we want to be accurate, we're going to say, okay, we're account for, this is the width of our trench. And that depth can still be 2 feet, 4 feet, 6 feet. But again, you're going to have, and I haven't marked out these, so I don't want to waste too much time looking at the details without because that's what we'll do in the other hour and a half of this 15 minutes that we'll be streaming like this, is to look in detail, look in very good detail, and see where they have the pipes running. So you can determine, okay, how deep do I need to do my trench. But again, chances are, if you're going to trench, is part of this grading plan too. So you're going to trench and you're going to grade. That trade is probably going to do that instead of the underground utility contractor. Okay, and then later we'll have a 15-minute live presentation on grading and what all of these contour lines mean, and what in the hell do we do if we don't have a section view of the earth. Okay, so that's another one, but let's go back to the utilities. All right, so that's about 15 minutes. I know this was my very first one to have a like and a view, so that's a good start. So we'll get the connection right. First 30 minutes of this, you can just fast forward right on through. I'm not even sure if I'll post it because of that, but I'll try to edit it and get started at the good stuff. All right, so please join me today at 12, and we're going to talk about, we're going to tear apart a Victoria's Secret from beginning to end. If you have any questions, please let me know at that time, and I will see you soon. Because really, everything in residential is more. So you would charge more for the hourly rate. Your fixtures would cost more. Everything would be more. But the main thing about the set of plans is that, yeah, the power components and the lighting components all on the same set in most cases. And again, you just have to take your time and go through everything in detail. And in this case, you can just go room by room, or just choose to do all the lights like you would if the set was separate. Just do all of the lights, count all of the lights, and what you know to be the lighting controls, and then try to make some sense of the wiring. Okay. Now, as you can see, just like in commercial with the lowercase letter, that means that these two lights are controlled together, and here's F here. So basically, dun here as far as your wire, okay? And this one, C, D, C, E. So that kind of makes it easy. Where your lights, which switch controls your lights, and so you can use that route, like all the O's. You can use that route. We got an O switch somewhere, 3-way switch. So it's going to control 3 different things. Okay, so that's not too bad. So once we do the takeoff, once you see my takeoff, you'll see. So all lowercase letters all are all together. And in this case, you can, because it looks like here is one of the rooms where you can cut the lights on here or from this entrance. Okay, so that's how, or probably somewhere else too. So yeah, just all mixed together. And this is the only sheet we get, and that's the exterior elevations. Okay, that's what the house looks like. So at least that's the exterior fixtures. Okay, and two bad thing is no. Okay, where is the? Here's the panel, but they don't give you anything more specific than that. It's like, well, got to think about in a residence, how does the power come to the house? It's usually overhead, right? Comes through overhead and then down a pole or something. So yeah, we would have seeing all that. It's existing, so we probably don't even have to worry about it. How is that? Oh, it's not from the ground up. It's a renovation. Who knows? But it is a. We don't care. Oh yeah, it's existing, so that's good. We don't have to worry about that. That's a clue that you don't have to worry about that. All that's existing. All of this is existing. That's existing, and the main thing, reason why you know you don't have to worry, is the meter is existing. So we're just doing probably just gutting it. It's probably been gutted and or they just when they built the track homes, they just put the basic stuff in, and now you buy the house and you get it all put in or whatever. Who knows? You customize it the way you want it. Maybe. I don't know. But yeah, so just know with residential, it's not all neat and there's not even a panel schedule. Okay, so with a lot of this, you'll have to guess in terms of even if you had to think about breakers, well, you would just uh, you'd have to go backwards, right? Because every outlet, duplex outlet, is probably for a home is 15 amp breaker. The electrician will know, but typically for every outlet you got a breaker. If it's a GFCI outlet, you have a GFCI breaker. If it's the mechanical equipment, you have a 2 pole, 3 pole, where all the other breakers are 1 pole, right? So you have to go backwards, but it's possible. But like I said, when we do this one together, you will see the takeoff. And I mean, in a way, it's easier, but then in a way, it's not. So just know you'll have to look at everything on one sheet. There won't be a lot of, there may be a lot of site work, may not be in this case. It is lots already existing. So if you have any questions, please email me at education@sfjohnsonconsulting.com. Otherwise, I will see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and this is a new one for our estimating class and for estimators, electrical estimators only. And we're going to be reviewing. This is just an introductory review to our Chase Bank that we're going to be preparing. It's a Chase Bank from the ground up. So not a very big bank. So we see the lighting plan, pretty straightforward, pretty clear, nice. Not a lot of keynotes. Well, on a lighting plan, we don't have very many. So we know that there is a panel called PP1, and that's where the home runs for the lighting plan are going to go. And if we're lucky, they'll show it on the lighting plan, but typically they don't show any of the panels on the lighting plan, even though it is for the lights. So, you'll be able to find it, or you may. Probably not, but it is on the power plan. Here's the site plan. This is kind of weird. Looks like they're going to have it go right over the building, because if it was underground, it would probably be a broken line. So that's kind of odd. Like this one is broken, right? Underground. Oh, it's far away. It's quite some ways away from the bank. That's the underground, the secondary. Okay. So we'll have to look at the single line diagram to give us what that is. And then the power plan, roof plan, all the disconnects, Got to make sure we know, again, as always, the wire configuration for the mechanical. We have a switch that can turn on a motor. So we got to make sure we have all the right ones for that. I don't know. It may come with the equipment, so that's something we need to check and find out. We won't have to look at the specifications with this one. I didn't include it, but on the ones coming up, I will give you the have a hotel coming up and you'll have all the specifications. You got to read through those. Okay, and so here we have a drive-through with some, I'm sure, and we know that it is the break off, right? So it's underground. That's also going to be underground, but they don't show it as being underground. The home run for see what. Oh, this has a lot of keynotes 4, 5, and 6, and a lot of just stuff. Okay, so yeah, 1 and 1 inch PVC underground routed to panel PP1. So always make sure you have for the transition from underground to above ground. And here are the panels. Panel PP1. And then that's the drive through. So yeah, we're going to go underground, and then at some point, because this is from the ground up, you may stay all underground and stub up, or I'm not sure. So that's something that we'd have to look in more detail. Most likely, maybe because they show us that this stubs up into the building where this remains underground because of so that's a lot to look into, because you want to make sure you are close to using the right conduit, because if this has to be underground at some portion, I mean it's going to be because of the distance from the building. So I'll just assume that this all is going to be PVC conduit until it gets to the building. Then we'll bring it up into over there. All right. And then a lot of details. See where our single line. I might have. Okay, so they have it like this, one line they have it vertically instead of horizontal. It's okay. Same thing. Utility transformer outside the building. Right? So we just have to find the distances in real time, pretty much in real life, from the power plant and include all of that. So that's weird that they have the single line vertical instead of horizontal, which we're normally used to seeing. Okay, so this is just a little Chase Bank from the ground up. Of course, we have all the details, so we have to make sure we know, and this will help you with we're using 1/2 inch conduit for this, so that's gonna make a big difference. So we normally use 3/4 inch, right? So when we see these keyed on the probably the power plan, we have to make sure we are using the right conduit when we see those marks on the plan. Okay, where the that's good. I rarely see it like this. Where of course, the power is 3/4 inch, and the data phone TV 2 inch. That's good. Duplex 3/4 inch. Whatever this is. Oh, data phone. Then the floor box. Oh, that's good. 2 inch, 1 inch, and then a 2 inch. What we got? Okay. Yeah, coming out. Nice. All right. So we can't get confused on so what I'm saying is, right, when you on the power plant and you see those things, you see, well, here, now we're going to need a 2 inch conduit to the ceiling for the data phone. And the whatever HB was on those details. Let's find it. Was it on this one? HB. Of course, I can't find it again. Let's see. Let's go back. Where was it? Yeah, here we go. HB. And sometimes it's not perfect, but should be an HB somewhere. There was one on the plan. Maybe it's just HB. Let's see. I don't see an HB. You know, it's always a mistake. Let's see if we see one here. HB, HB, HB. Oh, look. HBH. No. HB. Oh, we're getting close. HB. Nope. Yeah, it's a mistake. We'll find it. We'll assume it's 1 inch. Because it sure said, oh, let's see what 15 is. See the stupid stuff you got to do? But you have to do it. Hold up button. Oh, I like banks. Because you find out where all the hold up buttons are, which is good if you're estimator, but you're not supposed to, share the secrets. You know what I mean? And so, yeah, we'll find the conduit, floor boxes for the desk, different stuff. So, yeah, they keep us safe when we go to the bank. All right. So, if any questions on this one, let me know. This one won't be shared in the public because it is a bank. It's just for my students. And if you have any questions, email me at education@sfjohnsonconsulting.com. And to make sure you have at least 2 days a week, okay? Private sessions to go over this stuff, all right? All right. Let me know if you have any questions, and I'll see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, and I am here to talk to you about the project for this week. This would actually be project number 4 for our electrical estimating class, and this is a dentist's office. This is Conroy Family Dentistry, and we're going to do something a little different on this project where you'll have an additional piece of work to do, where I've also included the specifications in with your documentation, and I need you to review the specifications and tell me what the electrician needs to, what does it tell the electrician to do in detail. Give me detail in an email. What do the specifications state that the electrician needs to do? You know, when we do review a set of construction documents, I kind of been letting you off easy by not reviewing the specifications, but we know in real life we have to do that. And so I will have you, in addition to when your takeoff is due, also give me the additional information that is required from the specifications. And so photometric plan shows you how the light is, parking lot lighting is supposed to hit the full parking lot area. That's, of course, nothing we need. And here is our electrical lighting plan. Pretty simple. Bunch of 2x4s, a bunch of dome lights. It looks like, okay, the typical emergency. Okay, so pretty simple. Probably a lot of different, names. And what I want you to do, that this is that you could say, instead of counting individually, three-way switch, you could say that it is a duplex switch, right? It's a duplex, two gang switch. You can do it that way if you find that there are a lot like that. That's fine. You can do it that way if you find there are a lot like that. Or you can just do them individually. Either way will work. Okay. That's the lighting plan and the power plan. Okay, so dental offices, we're going to have some underground, some floor boxes, right? And that's a quad floor box. And, of course, dotted lines underground, power, and this indicates it comes up, right, up to from the nearest wall into the nearest power, right? So both of these are individual, because you see that they go to individual positions on the panel, right? So it's basically telling you that that's the home run, right? That this one's going to, but it's going underground, coming up individually, right? Because we can run more than one circuit in a piece of conduit, but we're just gonna do one for one. And if we see here in the rooms, right, both of these are going to position 16. So what we need to do is do that MC cable trick that they're not showing us here. So you can do it in the most efficient way, right? They're all going to, so it's not showing you MC cable, right? But we know that in our minds, if these are going to the same circuit, it's not like a home run that we can MC cable them here and wherever, right? Because they are going to the same circuit, as opposed to the floor boxes that we see that they're each going to a different home run, a different single position. Okay, so you want to look through all of your rooms now, because we may have multiple rooms, right? That have, because you can have up to six. Usually I've seen up to 6 duplex outlets, daisy chain pretty much together, and then home run da to this position. So you need to be aware of that. Okay, so when we do the takeoff, we want to see that 59, 59, 59. Well, zit, right? 72, 72 all together. So that's why sometimes you got to go in there and look, and like it's like 66 and 68, 64. See, it gets a little crazy. But the whole point, right? Going to the same circuit. So you got to keep your eyes open for that. Okay, so that's the power. The power is always more difficult. And then we've had our mezzanine, and then our roof, right? So we've got our disconnects. We got to make sure we count those, and we know because it's telling us going to 3 different positions in this panel. Likelihood it's not all number 12s, right? So we got to make sure we know where that is. We got to look at the panel. There should be some schedule somewhere telling us the rooftop unit or the mechanical plan power. Okay, so make sure we do that. All the disconnects, all the home runs. This is all on the roof, right? So we have to, in our mind, make sure we give everything an additional 10 feet to go down, right? Lighting and power. And then the single line diagram, pretty big, right? We go from outside. Okay, we got everything in black, unless noted is something we have to account for. So we see we have the conduit going down underground, then coming back up, right? And then staying up. And then the mezzanine part, so make sure you give an additional, to go up to the mezzanine for the power feeder. And remember, single line diagram, it doesn't tell us anything about distance. It's not to scale, right? NTS. So we have to go on our power plan, find out where all the panels are in position to what we see on wherever, right? And do the measurements. So this one was the first page. This is our HA panel with all of our breakers, so we know, okay, so here we go. So now we see from the panel our rooftop, our mechanical equipment wire. Some are number 12s, they're number 8, 3/4 inch. Okay. And then the next page is all the other panels. Then the lighting control panel, got a whole cabinet for that. Okay, so we have to look in detail to see what we have there and account for it in the material. And we see all number 12, a lot of number 12. So we're going to note, we're going to go back on our power plan and find the x-ray home run, and make sure we break that out. X-ray, look, X-ray home run. Okay, and all of the signage. Number 10, corridor lights. Got to pull all of that out when we talk about the home runs. Because remember, what we're talking about here is the home run wire. Whatever's home run, right? If we're talking about the wire at the panel, we're really talking about the home run. So we got to make sure that if something says other than 12, washer, dryer, okay, we got to make sure we account for those, and it's not number 12. And look on every panel: copy machine, compressor, vacuum, condensing unit, server room. Okay, so you got to go to the power plan, find where those are, and do the physical measurement from that home run to panel LB or wherever it's going. Details, all of our lighting, so we can see what it is. Sometimes you have to look at the lighting. Uh-oh, nobody's home. Sometimes you have to look at the lighting schedule to sometimes, because you'll think it's an individual light, and it's a string light, right? It's a string light. So you got to measure a length. I don't know if that's the case in this one, because I do these and I forget about them because there's so many to do. But you have to look because it'll tell you. Okay, so you have to say recess surface, and it'll say, well, what, string or something. You'll know, oh, okay, I need to measure where I see that, or it'll be noted like something like that on the plan. Okay, also site lighting. Make sure you look at the details of your site lighting, and I got to go back and put a video on that. I don't know, the other one we did, because chances are you're going to need a 3/4 inch ground wire, a grounding rod for each of the light fixtures. So make sure where is our site plan? They didn't really give us, those are, okay, so they didn't give us much of a site plan. Did they give the wire? I'm going to have to look. Maybe we're missing something. Yeah, because that's the plumbing plan. They didn't give us a detailed site plan. That might mean they're already there, but it's on the lighting schedule. So, but this is from the ground up, so they're not already there. So I would have to call the GC. Hey, you want me to just guess? Maybe yeah, that's a light on. Yeah, we're missing a site lighting, so I would have to get that. But we're going to work with what we got, and we'll show you when we do the takeoff how we work with what we got, because we don't have time to call these people, and they should have everything we need. All right, so that's that. That's the lighting plan. A lot of lights, lots of lights. Make sure you designate between the regular and the emergency, as it does make a difference. Let's see, power is a lot of stuff. Underground, okay, account for two powers coming up from the ground at each one of these dots, right? Because each one of these is a home run, basically. And it shows you whatever 2 is. Lots and lots of notes. Okay. See, underground, you have not only the power, but you also have 2 sets of conduits. So make sure you read that. 1/4 inch for the communication conduit. That's under there too. So 1 and 1. That's where wherever we have that 2, we have communication and power. That's very, very important. Okay, so if you have any questions, email me at education@sfjohnsonconsulting.com. But this is the one we're going to begin this week, and please subscribe and like and all that good stuff. And every month we have now drawings for $100 Starbucks gift certificate, $1,000 estimating credit for any company that listens, and free OSHA 10 and OSHA 30 certification every month. All that is each month. and you get the certification. Although now OSHA, you can have access to all of our study material for free, but when it comes to the live presentations, you need that to actually be certified, right? So you have to sign up and pay for that, but all the educational stuff, all the videos, all that stuff is free. So make sure you join, tell your friends, and I will see you later. Hey guys, thanks for joining me. This is Stacy with SF Johnson Consulting and Construction Services, and we are going to go over the full review of the OT Tennis Academy for our electricians only. And so, what we're looking at here is the site plan. Pretty simple. And this is a series of tennis courts, right? So, what we're going to have are a bunch of like parking lot light poles, and here they are. We just have to count them, right? And then, of course, all of the conduit is going to be underground, right? And it's going to be PVC. And so just follow, make sure we follow the notes. And in some cases, it's going to give you, right, it's going to tell you the home run. It's not number 12s. Okay, typically when it's that distance and for our lighting, it's going to be number 10. Okay, and so keep that in mind. So what you have to do is make sure you know where the panel is, where the main distribution panel is, with reference to the court. So it will be somewhere. You're going to have to look at the building, right? Look in the building. Oh, it's right here. I didn't want to tell you, but I just told you. Okay. So here, this is where it's at. And, this is pretty simple. So this is the site plan. Everything is pretty well outlined. Make sure you follow all of the keynotes. Okay. And allow for transition from PVC to either rigid or EMT, depending on where it's coming in at. Okay. And power plan and lighting plan, all on for the building, all on one thing. It's a nice, neat little plan, right? It's really simple. You can't really mess up, right? Just do your counts correctly. If you have a good counting tool, you're not going to mess it up. And 2, make sure you distinguish between the emergency fixtures and the ones that are not. Okay, because they cost a different price. They're different. Everything's different about them. Okay, so make sure you do that. And pretty simple for our power and communication. Your junction boxes where they're needed. Make sure you do all your home runs. And you know that unless it tells us something different, it's all going to be number 12s. Follow all the keynotes. Okay, and last but not least is our all of our panels. Okay, and so just make sure you get all of your breakers correct, and make sure you know how many positions in the panel, because the labors, depending on the number of positions in the panel, pretty simple. And then your single line. And what I normally do, right, when I'm doing my conduit, look at your keynotes. It's going to tell you the assembly for all of the wire. Okay, and so I normally just start here, and all of this stuff is really going to be on our on our Excel spreadsheet for all the switch gear, right? And I usually do this the very last thing. And see, this right here shows me that this is underground and it comes up, but it shows me this too seems to be underground and it comes up. So make sure you account for this portion of your conduit to be PVC, because it's going underground and it's coming back up. Okay. And so that's it. If you have any questions, email me at education@sfjohnsonconsulting.com. I will have my take up off. I won't have my stuff put up there until all of your work is due. And so if you have any questions, email me, and make sure to make your at least two times a week your appointment to work directly one-on-one with me. But thanks a lot, and I will talk to you guys next time. Hey guys, happy Monday, and this is Stacy with SF Johnson Consulting and Construction Services, and I just wanted to show you very quickly how to get into the OSHA site for the training information. And so you would go to, and everyone that's taken the class has to complete this. You get access to all the study material, and all the links will be active. But in order to get your certification, you have to attend the live classes, and which means you would have had to pay for that, which means you would have separate access when we do have the live, separate access to those classes. So if you have already purchased the class as a company or as an individual, then you know who you are. But everyone else, anybody else, gets access to all of the study material. And this is how you do it. So you go to our homepage, which is www.sfjohnsonconsulting.com, and go to the OSHA Live. It says free. And so to sign up, you're going to click that. And hopefully I haven't already used every one of my emails. So my name is Stacy and my last name is Johnson, and we're going to use a different one here because I think I already got one on that one. And let's see, let's do takeoffs. That's one of our emails. Okay, and so I'm going to create a password. Type my password. Okay, and that should be it. That's all you have to do. That way we'll be sent a notification that you have signed up. And now if you are the primary person for the business, this is what you have to do. You have to go down here because there are certain requirements for OSHA 10 and OSHA 30, which you have no choice. You don't pick those. But and OSHA 10, I do everything. So there's really nothing to choose in addition to in OSHA 10. And so, but OSHA 30, you do have to choose additional classes, which are down here. Okay. And so you pick the ones up to 6, I do believe. Yeah. 6 of the topics and or more, pick as many as you want. We have to cover those as well. So again, if you're taking OSHA 30, you need to pick 6 of the additional elective topics, and then give us all your information. So either way, we'll be ready. And every class is Tuesday through Saturday, 7 a.m. to 9 a.m., and then 1 p.m. to 3 p.m. On those days. So if you have any questions, email me at info@sfjohnsonconsulting.com. And again, just go to the free tab, fill in everything. We'll get a notification, and then we'll know you've been added to the class. We'll contact you with the actual login information for the live class, and we'll go from there. Okay? Any questions? Let me know. Thank you, and have a wonderful week. Hey friends, this is Stacy with SF Johnson Consulting and Construction Services, here to introduce a new segment of our educational program we call For Fill in the Blank Only. And this is for roofing and roofers only. And so what that is a program where we cover basics, estimating, and then safety related to that trade. And so we always start with the estimating or takeoff portion to introduce the trade. And what we have here is a small roof or a Scooter's Coffee. And this is the scope of work. So the keynotes on the roof, basically it is a TPO roof, 60 mil, over a half-inch DINS deck over poly insulation. Okay. And so what we need to do, we need to determine how many square feet of the TPO. We need to check to make sure if we have parapet walls, which we do. What is how many square feet of that do we have? Because chances are we're going to have the roof finish go over the parapet wall, right? And then we have some parapet caps, so we need to be able to, and this is typical for every roof, so it's not really anything, the square footage of the finished material, the cricket sizes, possibly um, how many linear feet of flashing for a particular purpose. Anywhere where there's wall and roof meet is usually a place to put the flashing. So I always give the how many basically the perimeter of the roof, and then any of the cricket lengths, right? And what's a cricket? It's just additional framing we place over the main framing to give it a slope so the water doesn't gather here, right? So and the arrows indicate the direction the water's going to flow, right? So we want the water to typically flow uh, in this direction towards the valley, right? Kind of early, kind of early. All right. So we want the water to flow towards the valley, and it's usually some roof drains or gutters, downspouts, and I'm sure number three that's what that is. Let's see. Yep, a roof sculptor. So what do we have to do? How many square feet in total? We have to measure how many linear feet the perimeter, because chances are the parapet wall is the length of the parapet wall goes the perimeter of the building. We're going to look at the section views. That's a building section view, so we can see the thickness of the insulation and all the other details, right? Because from the plan view, we can only determine how many square feet of the finish, plus we can determine how many linear feet. And so for the roofer, square feet of the finish, always determine how many square feet of opening we have. And this is an opening for a rooftop unit or condensing unit or something like that. Then we want to know uh, how many square feet. And, it's a circle, so we just square it out because we do want to be able to give to the roofer how many square feet of opening, because they're going to deduct that if they want to. I don't know. It's just waste, right? Deduct that from the total area of the roof. So, area of the roof, perimeter of the roof, because we're going to have to look at a section view to determine the parapet height. So, let's go here. So, we have four different building section views. So, what this is now this building section view is good for a bunch of people. It's such a small building. So, it's good for the framer if we need to know the full height of those. God, I can't even think. The full height of the shear wall. Shear wall height usually goes the full height of the building. So now I know that the shear walls are going to be this height. So I can use this for that, I can use it for the thickness of the insulation. I can use it for finished carpentry. This looks like two top plates and another, and it's most probably at the perimeter of the building. And so for my roofer, tells me my roof finish, right? And I can look and see that this is the board insulation as opposed to the bat insulation. And if I'm the insulation professional, I can use this too to determine the height of my insulation. A lot of good things from this view. But because we are the roofer, we have to make sure we go to the next view. Why? Because this is a call out, right? A detailed call out, meaning it's telling us it's going to call out just this portion of the building. And because we're the roofer and our roof is showing right here, so we know that our parapet wall, it looks like it's a different height, right, based on the side of the building. So we have to go back to the roof plan, and the 1 over 3.1 would be the height for these walls, because that section view goes through both walls. So that indicates that both of these walls are based on that height. Now, once we get here, it's going to change. we're going to look at 4 over 3.1. So if that parapet wall happens to be a different height, it's going to be at this point forward. We're going to calculate the different height. But for this whole section, till we get here, it's going to be whatever height is shown. And then these also have a different. Then we'll look at 2 over a 3.1 for the height of these parapet walls. Because again, we can see that the parapet walls are a different height. Okay, so that's how we get that. So we go to, because I want to go to more of the detail view. So I'm going to go to 4 over a 3.3. 4. It still gives me another detail call out. So I got to follow every one of them because I'm the roofer and I have to make sure I followed every detail call out until there's no more. So I still know a lot about this. I know that my finish is going to go up the parapet wall. I know I have a 22 gauge metal parapet cap that is this width, and I still got to go to 7 over 3.4. 7. So you got to have patience. And because you don't want construction defects, right? You're going to make sure you go to every view that you're sent to. And so we see here that there are no more views, no more call outs, no more anything. So this is the final of the views, the final of the detail views. And so as the roofer now, I know that I need to do all of this for my parapet cap. And I know that even the rough carpenter is going to come to this view too. Or have it, because they need to do all of this. And then, if you're doing the siding, then you're going to come here too. It's going to lead you here too. So all of the views are based on whatever you do. If I'm the flooring professional, right, I'm not looking at these views because it's not my scope of work. But if I'm the rough carpenter, the siding professional, the roofer, all of these, it's my scope of work. Okay, so I have to go to every view. And so now I know that in terms of, because I'm looking at the plan, right, for my takeoff. And so I know that even for the rough carpenter, I know I have 2 of these top plates. So 2 times the perimeter of the roof, if I'm doing my takeoff for that, I know I have the sealant, continuous caulking. So I know how many linear feet of caulk I have. So I know from the container how many linear feet of caulking, 8 ounce, 16 ounce, 32, whatever, a bucket, whatever. So that way I can do a proper takeoff to do a proper material determination, material cost determination, right? Rain screen, high performance weather barrier. You don't want to miss out on any of that because if you do, chances are it's going to leak and you're going to have a construction defect. And if whatever trade was your trade, you'll be responsible for all the other trades that got damaged because you failed to do your portion. That's what I did for a living, construction defect litigation adjuster. That's why you get that insurance. So just in case you don't show them, you don't know how to read a set of plans, you don't get to the detail call out number 6 or whatever, and you forget to put something in your construction and you blow it. And it leaks and somebody gets sued because now the whole building is leaking, right? Yes. No. So you want to make sure you know how to read your plans. Okay? Come to the construction queen. I think this is the only time I ever referred. It's like, what were you thinking when you came up with that name? Oh, probably a shot of tequila. See, I'm perfect for this job. Anyway, roof plan. Okay, so here are our wall curb attachments. So whatever this is, you got to make sure you account for it. It shows you how they want it up the wall, right? Because, well, what's the purpose of the roofer? To make sure no moisture gets in the building. Okay, so that's why we have the TPO roof on the roof and over the parapet, and with a parapet cap, with the caulking, so water doesn't intrude into the building. Okay, and so what do we do as the roofer? Square feet of the flat roof. Now we know we have to break up the section view, right? Because at some points this parapet wall is 3 feet, some points it's 5 feet. So we have to do 5 feet times however many linear feet. So we're accurately determining the additional TPO for the parapet wall, right? And now we have to measure how many linear feet for the parapet cap and whatever else goes with our scope of work. And we have to make sure we're doing whatever this tells us for the openings, whatever this tells us, number 8, whatever this tells us, number 5, 6. Vent, that's easy. So we got a flash and it's going to show us at 5A. Let's go to 5 over A 3.6. 5 over A 3.6. 5. I never pan in the first time right. Okay, so here's the vent pipe. Right, because what's the point? We don't want moisture coming into the building. So we have the vent pipe, that's the plumber. And now we have to do all of this. We're the roofer. Okay, and so you need to know how to do it and how to account for it. And so it's a vent pipe, so it's a circle. You could treat it like a square. That's fine. When you're doing actual takeoff numbers for, okay, how many linear feet of TPO to what point, and it tells you, I think, stainless steel clamping ring, sealant. See, what's the point? So no water gets down in there. So you have to be able to follow every section view, detail view. So you're doing the right thing. Okay, roof deck, rigid insulation. And if this is to scale, which it is, then you can just measure what's the thickness of the insulation. That's the whole point of having something to scale. You don't know. It's like, 4 feet, 4 inches, 6 inches, whatever. What is this? This is different from that. So you got to make sure what that is. Okay, so it's fun. It's a lot of fun. All right, so roofer, you are going to make sure you know how many square feet flat, how many additional square feet for your parapet wall, parapet cap, all the goodies that go with that, and know the heights. That's why they give you the section views, because the section view marker is if what? This is, we cut down in 2, and now we're opening up and we're standing in here and we're looking at the interior construction so you can have a better view. And then that view will take you to a detail view most likely. Okay, and take you to all of these other places so you'll know how the vent pipes come and are flashed, and how let's see what 7 is. We didn't look at 7. Air condenser, see mechanical drawings. Okay. All right, so if you have any questions on anything that we presented, please email me at education@sfjohnsonconsulting.com. So in addition to this, we'll have stuff like safety for the roofer, what the project manager needs to know from a roofer, from that kind of perspective. So join us every day. We have something good for you. And if you like the video, please let me know. And again, email me at education@sfjohnsonconsulting.com, and I will see you next time. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, here to talk about number 8 on OSHA's top 10 cited violations, which would be a failure to have and be able to prove fall protection training. As we know, falls are one of the leading cause of death and injury on the construction site. And so in every case, I'm almost certain you need to have a fall protection program and proof of such at your job, and proof that everyone there is getting the training. So it's the OSHA standard 29 CFR 1926.503. Subpart M, safety and health regulations for construction, says this standard underlines the requirement for the employer to provide a training program for employees that may be exposed to falls. Training must be performed by a competent person, qualified in the nature of hazards and details of fall protection systems. The employer must have a written certification of training on file. So that's the important part, because if it didn't write it down, it didn't happen. And so here's the actual standard from OSHA: must have the training program for employees who might be exposed to fall hazards. You got to have the program. It's really just that simple. So I'm going to show you our page that we teach from OSHA's fall protection training. Just a small little video to get us started. All right. OSHA makes the world go round. All right. So, how can you protect yourself from fall hazards? Well, first of all, the use of fall protection equipment. We're not going to go through everything, but this is kind of the beginning of what we teach. Basically, the safe use of ladders, and of course, you got to have your training. But the most important is the fall protection equipment. You know that the employer is totally responsible for providing that on the job site, and so the one they prefer, if you need any at all. See, the goal is to never even need fall protection, but if you do, then there are three that are recommended. Guardrails, of course. Those are a passive system where if they're there, you won't fall. Okay, where also safety net systems is if you fall, something's there for you. You get in the net and they'll take you out of the net. And then the personal fall arrest system. It's an active system. You have to wear it. It has to work right. It has to employ correctly in order to save your life. So you really want to not have the need for one, but if you do, guardrails are the safest. And of course, if you're up higher than 6 feet, you're going to need some kind of system to safely get you to the ground. We go over scaffold work. If you need the personal fall arrest system, if you're higher than 10 feet, and then we go over safe ladder use, and then all of the training. Okay, fall protection guidelines. We go over all of that. Understand the company's written fall protection plan. So there's the there's the violation right there, right? Let's get a little something to drink here at the office studio. Yeah, that's the problem right there. Written fall protection plan. So, if you have people working for you, you want to keep them safe, right? You have to plan. You have to actually do the training. You have to use the equipment. The employer has to provide it, has to replace it. But if there is evidence that the employee damaged it on purpose, then the employee has to replace it. Okay, so that is number 8, the violation. You got to make sure you do what's right. Okay, so what are my employer's requirements? Of course, to provide the fall protection, to ensure if you're going to use scaffolds, there's a system, there's a requirement in OSHA how to do it safely. Yes, we need to train you on the use of ladders, even though it seems very simple. And yes, we must conduct work site maintenance. These are all things that will assist you in staying safe from falls. And then, of course, to provide the training. Okay, so it's a lot of a lot of stuff that appears to be repeated, but these are the actual standards that go with proper scaffold construction, the standard on the scaffold. And we went over a lot of these on the previous because, yeah, these are things that everything related to falls, pretty much the fall protection, the use of ladders, the scaffold, pretty much OSHA's most cited violations. And so maybe that's why falls are the leading cause of injury, right? And death. So fall protection training, all of that stuff is very important. So if you think you are in need of it, or if you are in need of it, make sure you contact us. We set up individual fall protection training for the individual and for the manager, so they'll know what to teach. So if you have any questions about this or anything that we have presented previously, please make sure to send us a email at education@sfjohnsonconsulting.com. Otherwise, I'll see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services. And in this video, we are going to go over some structural framing for our class and our special segment on our website for framers only. This is the structural set. And in the structural set, this is the cover sheet. You know, the structural set talks about all of the concrete framing components, posts, anchors, concrete masonry, everything related to the structural set. And so in this set, we're going to talk about the structural framing. And what is structural framing? It's the shear walls, it's the posts and columns and headers and beams and how they are connected and supported. And so this is a small coffee shop. And the first sheet that it gives us is a configuration of the shear wall. So it's the shear wall plan. So it gives us the shear wall schedule. And what is the shear wall? It's additional framing that you put over the structural framing to give the walls more resistance to shears. To in this case, is showing drift for snow or for wind shears or earthquakes in California. And so you give the walls some additional structural components to make them stronger, basically. And so, what is a shear wall? It's basically just plywood on the exterior portion. Well, because it's right, it's at the for the rough framing. We're not talking about drywall. We're not talking about framing that's on the architectural set, right? So it's just so we have the rough framing, and so we're going to connect the shear walls at the frame of the structural walls, and it's nothing but plywood, okay, 1/2 inch plywood, and it tells you how to place it basically between the posts, right, and how to nail it. Okay, so what is this? 10D at 6-inch off center. So shear wall 1, the hold downs are these. It looks like all the hold downs, no, they're not the same. Hold downs are as listed. Then the anchor bolts are as listed. Okay, so 10D is the size of nail. 6-inch OC is, so we're putting a 10D nail every 6 inches on center. And the hold downs are as such. So we're going to have to look at, if we really want to get a good look at this, we have to look at the structural sections, right, in order to see exactly how everything is placed. And so the anchor bolts, this is the size. And for shear wall 1, they're placed every 2 feet, and we work our way down to every 32 inches. So basically, it shows us here. So wall B, and now we have Uh, these are wall B. And so now this is just the shear wall, and we have to go to the other page in order to find out, well, what is B? What's the configuration of B? What are we talking about when we're talking about B and A? And that's on the other sheet. Okay, so this basically just shows us the shear wall configuration, and we have to use this in conjunction with this. And so, what's A? What's B? What's one? What's two? Here's the actual roof framing plan, and then the foundation plan, which in the foundation plan, they also kind of mix up your, they put everything that's for your framing here. So, it's kind of like, for my liking, I don't want the king studs on the foundation plan, right? Because the foundation plan is concrete, right? For me, it's a one. See, we have a single story building, right? So it's kind of like, okay, do I put it here? Do I put it there? But because it is framing, we should put it on the roof plan. But every architect is going to do something different. So, what is my job? Let's go back to what my job is. As the framer, structural framer, I have to be able to do the takeoff for this thing. That's really so I have to do the takeoff for the shear walls, and I have to do the takeoff for all of the king studs. How many? What's the height? I have to do the takeoff for the headers. How many linear feet of each type of header? What is B? So that's why we have to use this sheet in conjunction with the sheet that we already saw. What is B? Well, B is the header. And what's a header? Header is, let's go back. When we put see, that's what I don't like. It has the header here and the header here. But no, it doesn't have the header here because it doesn't mark it. It only has the king studs here, but the header's over here. Okay, so what's a header? That's header B. Anytime we put a hole in a structural wall, and a hole is a door or window, you have to give the strength back to the hole so we can place the roof joists and they can be secure. So we put headers in doors and windows. So it's a combination of 3 or 4 2x4s, 2x8s, 2x6 with the plywood to fit the gap. So let's go back to see let's go forward to see what header B is. See, I kind of don't like when you got to go back and forth. Everything that you need on one set should be on the set. There's no reason why they couldn't repeat this on the sheet that we actually need it on. So it's like, oh, if you're new to this, I'm like, okay, well, what is this? And yeah, when I was new to this, it drive you crazy. It's like, well, wait, where's A, B? Oh, it's on a different sheet. It should always be on the same sheet that it's referenced. But in this case, it's not. So we have to keep going back and forth. And so what I would probably do is just print this out. So when I go to the next one, I'm like, okay, what's header B? Okay, I already know because I printed this out. Okay, this is a pain, but it is what it is. You know what I mean? You work with what you got. All right. So what's header A? It's 3 2x10s. We know the by is wood, right? X wood with 2 half-inch plywood spacers to fill the gap, basically. B is 3 2x8s with 2 half-inch plywood spacers, and header C is 3 2x6s with 2 half-inch plywood spacers. So when you're doing the takeoff, you're basically saying 2x10 times 3. So if I measure 25 feet, I'm really going to say 75 feet of a 2x10. That's how we do that. And half-inch plywood spacer, half-inch thick by half inch by the width, by 2, half by, because you need a height for to be very technical on your takeoff, right? You need a height and a width for that plywood spacer. So you just got to sit there and, do the math. It's easy. Okay, so some stuff is over here now. What's B? Shear wall schedule. See, but this B is nowhere on this, right? Because this B, well, where's 1 and 2? See, 1 and 2 is nowhere on here, so I hate this set of plans. So what we're going to do is we have to measure 1 and 2. That's here. That's all of our 1. Because your shear wall isn't continuous. It's only where it's noted. Okay, so that's confusing too. That's why I decided to get a very confusing set of plans. Okay, because here's the shear wall, here's the symbol. So when we see octagon 1, 2, 3, 4, we need to look for octagon 1, 2, 3, 4. Okay, so that's here, octagon 3, and it is only where you see these symbols. So it's not everywhere. Okay, so that's a pain. So we'll do those measurements. Okay, and remember this is for framing only. So what do we need to measure? The length of the shear walls, how many linear feet. Then we're going to go to the section views. And see, these section views don't help because they don't go all the way to, they don't tell you the height. Okay, it shows you, see, it breaks it off right here because this is the header. Man, this sucks because your shear wall is going to go the full length of the wall. So this right here is the header. Where's the header? Header's at the top of the window or the door. And so you have to figure out what's the top of the window, and it tells you right here. Reference the architectural set. So you see how difficult it can be to navigate when you have a crappy set of plans. And what's our job for framers only? Measure how many linear feet a shear wall, and you got to figure out what the height is because you need square feet for shear wall. You got to determine how many linear feet of the header. See, this is the one with the 3 or 2 or whatever plywood header, and then it tells us to reference the plan. So this is from section view 2 on there. Okay. And so, yeah, it could be a little difficult. But this is just the basic overview of the plans, right? We got to get a basic overview. We're the framer. Basic overview is kind of crappy because framer, we need our rough framing. 3 king studs and 1 jack stud at rough opening typical. So whatever I see here, so that's why they don't have to mark this one, because they've already marked it here. They gave me the details. Typical means this picture right here, whatever I see that represents this picture right here, which is like what, this one, that one, that one, that one. Oh, see, no. Okay. So corners, typical. So the corners, we know we have 5 at the corners because it told us. Typical is the key. And then at the openings, we have this configuration, typical. And this is an opening. And I just have to know it's an opening because I should know it's an opening. This represents an opening. Okay, so a little confusing, but not really. So again, what am I doing? Measuring how many linear feet of shear wall. This represents the shear wall, octagon 1. It's only this many linear feet. But at the corners, I have this configuration and that. So I have to measure what? 5, 10 king studs times 15, 20, 12. I don't know how many linear feet because it's going to go from the foundation, right, to the, the roof joist. So I have to get on another set of plans if this section view doesn't show me, which it doesn't. Okay. It only shows me the from the header all the way up. Now, it's very confusing because I have the shear walls. Let's go back to the shear walls. Well, we know that the wall is let's go back to the floor plan, right? Floor section view. Here we go. Okay, so now we're at the in the architectural set. It's not telling us anything about these, right? That's our header that we're looking at on our structural set. It's not giving us info about that. But see, we have to go here to determine the shear wall height because there's nothing that tells me, and shear walls are usually that's the whole point, to attach it to the foundation, to the roof joist, and then above. And so that's the only detail. And I would just, when you do the estimate, you just got to be very detailed on how many linear feet, how many square feet of shear wall are you allowing for the plan. You got to be very detailed, especially when the plans aren't detailed. You got to write out a lot of stuff because you want whoever's reviewing your estimate to know that you've done the best based on these plans that you're given, right? To get the correct numbers. And so over time, we'll have the takeoff completed, the visual completed so you can see it. And you also have the pricing from a cost book. And then with the cost book, we'll be able to tell how long something takes. That's the beauty of this whole thing because you want to be able to price it correctly. If you know how long it takes, you'll be able to price it correctly. You'll be able to know how long each job you do is going to take. And so you'll be able to schedule work for the whole year, right? If you have 5 jobs and you know exactly how long they're going to take, you know if you need more work for the year. You can't just work, oh, I think this is going to take 2 or 3 weeks. No, there is a way to determine once you have your full takeoff completed, how long this job is going to take to do every portion of the scope of work. So let's go back because this is for the framer. Okay, so the framer, what I'm going to do is shear walls. I got to measure how many linear feet of the king studs, right, from foundation to roof joist. I have to determine how many linear feet of the headers over here. How many linear feet of header I have. And now, how do they represent the roof joists? Structural framing and always represent it with the arrows, the sweeping arrows. So I know the full roof joist configuration. And if it was if it's something different than 2x12s, it would have another sweeping arrow and give me whatever that is. And so the full roof joist, structural roof framing is structural framing. We know that it's all 2x4 at the 16th on center. And then we have to look at, because we have a hole in the roof, right, to hold the condensing unit and the air handling unit and whatever unit. So these structural roof joists have to have their own additional structure to keep the air handling unit from falling through the roof, right? Okay, and so for the structural framing, there's a few totals that we'll come up with. All of the headers, all of the shear wall totals, all of the roof joists. Now you can do the roof joists because you actually buy roof joists based on not square feet, but how individually, right? In all of these individually, and it appears that the majority of them is are 17 feet 11 inches. So that's good for this one, because if the building was built another way, then we'd have to tailor our roof joists to fit that length, right? Because these are made specifically for the building. Okay, so again, for framing only, what do we have to do? The structural framing, not architectural plan framing. Structural framing, architectural plan framing, two different things. So this is S plan as in Stacy. So what do we look for again? Shear walls and posts and columns. Basically, these are acting as uh, posts. Pretty much, these are acting as posts because it's single story. You don't need anything to other than that, but that's a lot. These are uh, posts or columns, whatever you want to call it. Call it either one. They have the same purpose. So again, I repeat myself. Structural framing, what are we measuring? Shear walls, and that's all is represented by this configuration. And on the other sheet, it told us what octagon 1, 2, 3, 4 plus the anchor bolts. So really, we can determine first if we know how many linear feet, and it should tell us more about the nails. It's like, okay, 10D nails at the 6 inch. Is that at the framing? See, we got to look more in detail on the nailing, because it's just, yeah, every 6 inches, but at the corners on in each direction. So that's something else you got to look for. Okay. And you can figure out how many anchor bolts you need if you know how many linear feet. You're placing them every 2 feet. So you figure out how many anchor bolts you need, the hold downs. You can really determine how many nails you needed if you wanted to. Okay, so shear walls. And then we say, well, how many linear feet of shear wall? Octagon 1, 2, 3. Figure that out. Then all of the corner king studs, figure that out. All of the headers, how many linear feet of whatever configuration it says it is. So, right, no, headers. So remember, it's not just one stretch of 2x10. If I have 100 feet, now I've got to get 300 feet each cut that size, right? Because within each opening, I have to put 3 plus 2 1-inch half plywood spacers. So that's what the structural framer does. Got to figure out all those totals. We'll have all of that done shortly in a video reviewing all of that, and then we'll have video 2, which is pricing, and then video 3, which is formatting an Excel spreadsheet so it can look nice and pretty. And so if you have any questions related to any of this, please email me at education@sfjohnsonconsulting.com. Tell me what you think about this. It's very crazy, right? This is not a very easy one. Structural framing, like electrical, a lot of little details. If the plans aren't really good, you got to go back and forth and back and forth. And you can't make mistakes as an estimator. You got to make sure everything is right. So you have to take your time. So you'll see once we work through this little by little. And again, any questions, please email us, or otherwise, I will see you at the next class. Hey guys, this is Stacy with SF Johnson Consulting and Construction Services, going over OSHA's 10 most cited violations, number 7, which is powered industrial trucks, or more likely the improper use of the powered industrial trucks. And that is OSHA standard 29 CFR 1910.178. 1910 subpart N as in Nancy, material handling and storage. And this standard contains the safety requirements relating to fire protection, design, maintenance, and the use of powered industrial trucks. And so, basically, fancy term for forklifts, tractors, platform lifts. It could be any specialized industrial truck powered by electric motor or internal combustion engine. And there are, 11 different designations. Okay, so it just basically goes over the standard of each, what's required in the training, and we're going to get that up here. So we have this in a little video. We want to drive the forklifts around like they're sports cars. So basically, if you are using one, you have to be properly trained. It has to be noted that you've been trained, and you have to be trained every 3 years. And the only additional training would be required if you were found to be using, the forklift improperly. Then yes, you would have to be required to be retested, recertified, and all that good stuff. So that's what would happen in that case. So really simple. This section contains safety requirements related to the protection, design, maintenance, and use of fork trucks, tractors, platform lifts, da 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 da. All new powered industrial trucks acquired and used by an employer shall meet the design and construction requirements. And then it just states that there are 11 different types. And then there is more information on where and when you can use each type. And so we have a little video here to go over the most important things when it comes to that is just you don't modify it other than you don't do anything to it other than the manufacturer's recommendations. For instance, even if it is 110 degrees, you can't put an umbrella, stick an umbrella on the top, right? Because that's not according to manufacturer's specifications. I know it makes a lot of sense, but you'll get a violation because of that. Okay. So let's show this little video. And it is very outdated just to show you how long we've been trying to keep you guys safe. Here we go. I'm gonna cut the mic off, and hopefully this time again, I'll remember to cut it back on. We'll be right back. Isn't that awesome? It's awesome music. The dust and the particles, but you see there. This is Stacy with SF Johnson Consulting and Construction Services, and this is an episode of For Plumbers Only. And we are going to be reviewing a set of construction documents for the plumbing plan and for the plumber, and we're going to review. This is a project from the ground up, so we're going to review first the utility plan, and that is the plumbing that would take place outside the building. And then once the plumbing gets into the building, then of course we're going to look at the individual plumbing plan. And so this is a very small same little project, this coffee house that is going to be built from the ground up. And so what we're going to look at really is everything that's related to the plumber's scope of work. So WL, that's the water line. And so what we typically do, right, is we tap into the utility line wherever the public utility water line is running along the street, which they do, right? We tap into it, and then we bring it into our new building. And then underground utilities are always, well, it really depends on the state, but we're going to assume PVC and for the underground utilities until it comes into the building. So what we always do first is look for the scale. It's the same scale for 1 inch. It is 10 feet. We've already scaled it. That should be 5 feet, which is correct. And so for the plumber, what we're going to do is just look for all of the plumbing scopes of work, everything related to the plumber. And so we have the water line, and the water line is going to tell us, we're going to look somewhere, it's going to tell us the width of the water line. Okay. 1.5 inch. That's the water line. And that's why I like looking at these when I do the recording. So it's so I don't whip through them, right? I have to take my time. So we have the water line, and then we also have an irrigation line that which is, probably the same PVC. And so what we'll do here is WL, our water line. You know what? Let me go back because it's hard to see when it's not caps. So our water line, and we know we're going to go back and so you see all the angles, right? We know that we're going to have 45s and 45s, right? Until it gets into the building, water line. Yeah. Let's see, where else? Sanitary sewer, SS. Okay, and it's going to tell us somewhere what the size of that is too. So, it's a 6 inch. So we don't care right now. Well, we always have to go back and check. So we'll see the SS, and it's going to come here. Proposed sanitary sewer. Yep, all the way here. This is some kind of manhole test system or something. It should be noted though if it's something that we need to really look at, like this one. E, that's electrical. So our utility plan has the electrical, right? But our electrical plan is always going to have its own site electrical. So just in case the site electrical is missing something, we don't really need to look at this one for the electrical. And then I'm going to take this all the way to here. And now this is a 6x4 reducer. Okay, so I have to account for that because that's part of my plumbing scope. All right, that's that. Now, what is all this is what we want to talk about. So that's that. So basically what it's telling us, it's a 6x4 reducer. And this is giving them the elevation of the 4 and the 6. Okay, just a little off by what? 1/10 of a m, whatever this is. It's based on GPS coordinates. And so that's what all of that is. 6x4y. This is the GPS coordinates. So when they set it, they know exactly, so it'll fit to where we're setting the pipe, because the pipe is run. Then we have to set it into the component, right? And sample, proposed sample well. That's our plumbing scope of work. It's 4-inch. Okay, and then we have a grease trap. It's the grease trap. That's also a plumbing scope of work. And it looks like this is a 4-inch, right? Because this is the grease trap. Okay, it has two, one in, one out, in and out. In there, it's telling me it's 4-inch. So I'm just going to go ahead and I'm going to say the grease trap. So GT 4-inch. So I know this was what was going in and out of the grease trap. And you know all this is underground, right? So I'm just going to go through for waste purposes. right? So this is a 6x4, so this is got to be the 4, and the other end is the 6. Okay, so plumber, site, work. Let's see, that we always take our time. And then, yeah, we have to count for meters. And yeah, the size makes a difference. So the irrigation meter is an inch, and then the domestic water, domestic, I'm sure, domestic, I don't know. I'm not thinking. I've done a million of these today. So that's, yeah, for the water, and that's for the irrigation. And the irrigation plan is also, I have to look on the landscape plan. It should also show our irrigation on the landscape plan. It may not, because it's showing it here and they're trying to get more bang for their buck, so it may not. So as far as the plumbing, okay, grease lines, 4-inch sewer connection, 1.5-inch water line. Yeah. So that's once it comes into the building. So now we look at the plumbing plan, right? Because that's once it comes into the building, we transfer to the plumbing plan. So that's the plumbing specs, plumbing notes. So what are we going to be installing? So we know we have the sanitary waste, water, condensate pipe for our HVAC equipment, indirect drains, okay, and then the kitchen equipment, right? Anything related to the plumbing scope of work. So the ice maker, coffee maker, espresso, da 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 da. And of course, we also always need to know the size of the pipe that's coming in and out, and the vent pipe if it applies to all of the equipment, whether it's the kitchen equipment or the plumbing equipment, the lav, which is the term for the sink only in a bathroom. So when we see lav, we know we're talking about the bathroom sink, and the cold water, hot water, waste, vent. Plumber needs to know the sizes of all of that. So we look through, make sure we know the typical symbols. Da 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 da. Da 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 da. Okay, we got the recirculation pump, mixing valves for probably the bathrooms, right? So we just instantaneous water, instantaneous heat. That's what those are for. So we don't have to worry about water heaters for the bathrooms, sinks. The expansion tanks, always got that. So always have to make sure that you are noting all of your plumbing equipment and the sizes of the pipes for water, hot water, cold water, vent, waste. Hold on 1 second. We're going to have a frosty drink for 1 second here. All right. So you have to know all of your equipment because of your rough ends, right? So you're going to have a rough end for every piece of equipment. So if you have 10 lavs, you got to have 10 rough ends. Okay, so you got to make sure. Now we go to plumbing details. We see our circulation, recirc pumps, our backflow preventers. So it's like, oh, I used to take my walks all the time, and then I would see those. I'm like, oh, now I know what those are. You always see those on the outside of buildings, right? These big things, maybe if it's a place where it's cold weather, they'll have the little green insulation jackets over everything. Construction makes you smart, let me tell you. All right, so that's so the plumber can see what the elevation views pretty much of their plumbing scope of work is supposed to look like. Typical, right? That's a typical reduced pressure black backflow preventer. So meaning they always use the same kind. All right, so let's get to the plans. So we know the difference between the riser on the left and the plan on the right. The riser will give us all of the horizontal measures. So all we got to do is get to it. Right? We have two plans for the plumbing. So we have the sanitary, and then we have the the sanitary and the vent plan. Then we have the hot water, cold water plan, and gas if there is gas in the building. Okay, so this is just the sewer plan and the sanitary riser. What does the riser show us? The vertical measure of the pipe. And so, yeah, we always need the riser. It's always a great set of plans that gives you a good riser because you can determine because we have to determine our material costs, right? Our material quantities. So, yeah, we need to know for plumbing what's the vertical measures as well as the horizontal measure. The plan is giving us all horizontal measures, right? This is all horizontal measures of pipe. But the pipe go up and down, and that's the purpose of the riser. And so every time I see this is a vent, right? Symbol for a vent is the broken line, right? We have broken lines in a lot of cases, so you got to make sure you know the difference. On a plumbing plan, broken line means vent. On a demo plan, broken line means demo. Take it out. Underground uh, uh, on a grading plan, broken line means probably underground utility, and it's gray broken line, underground existing. So you got to know based on your plan what that symbol means. But for plumbing, broken line always means your vent. So this is a 2-inch vent line, and what you'll see on the plan view is the horizontal measure. The riser gives you the vertical measure. That way you can measure up and down and you don't mess up on your material quantities. Every time I see up and down, I say 10 feet, period. Rule of thumb for me, right? Because a building is between floor to floor is pretty much 10 feet. And this is a single story building, so you can give it a vent to roof, right? Vent to roof, you see the vent to roof. That's going to be out the roof, up out of the building. So I give that one an extra 2 or 3 feet. Okay, 3-inch vent roof plus the little vent roof thingy. Okay, what else? All right, for what the riser diagram is very good for is to count your equipment. Sometimes it's difficult to count your equipment from your plan. Sometimes it's okay, sometimes it's not. It really depends. So, but you got to recognize that there are some items that are on your sanitary riser that's not on your cold water, hot water riser. The clean water, I call one the dirty water plan, which is this one, sanitary, right? It's all the waste vent. That's the dirty water. That's the sanitary plan. Okay, you say nothing mentions hot water, cold water going to any of these components, any of this equipment. This is all the sanitary plan. The next plan is the water supply plan. And if there's gas running in the building and it's not a lot of gas, unlike a dental office where you may have a separate plan just for the gas lines and all the different gas that a dentist has, or anybody having a lot of different gas lines, they would probably have a third set of plans for just all of the gas pipe. So this is the second plan, which is the water plan. So all of the pipes go to the same components, different size pipe, 2 dot, 1 dot. 1 dot is cold water, 2 dots hot water. You got to look on the schematic. You got to look on the symbols to make sure. And then here too, we have a riser diagram, which means the up and down vertical measure of the water. Same thing applies. It's going to show you the size, and these are the controls. So everything you see here you have to account for it. Okay, and so every time you see it go up, well, I have 10 feet of 1/2 inch, and water pipe is typically the copper pipe unless it says otherwise. And sanitary pipe is usually PVC unless it says otherwise. Sometimes it's cast iron depending on the state and if it freezes. I know New York, for some reason, I keep thinking New York, everything has to be cast iron unless it's some other, like hotels. Once it enters the hotel room that has courtesy sinks and wet bars and stuff like that, then you can use a different kind of plastic for those types of situations. But okay, so plumbing That's why plumbers can't mess around and have somebody that does not know how to do a takeoff. Because imagine if you don't consider the vertical measures. My goodness, you're screwed. And the rough in cost. Rough in cost again is the additional cost for the piping systems that apply to the cold to the dirty water plant and clean water plant for the first time that you install that piece of equipment. So when you have new construction, not renovations pretty much, because with a renovation, unless you're installing like an addition that has a brand new plumbing system where a brand new toilet is now introduced into the home or whatever, not just where you took an old one out and put a new one in, there's no rough in cost associated with that. But when you have a project from the ground up, it's very important that you include the roughing cost, which is the additional piping systems for both plans the very first time you install that piece of plumbing. So it could be anywhere from, depending, it could be $1,000 for a shower roughing cost. So you never want to exclude that, and again, especially for new construction like this is. Okay, so what we would do on this one, we just got to get a good takeoff tool. What's the scale? 3/8 equals 1. And we just, you just got to take your time. And like 1/2 inch. Now, I normally don't differentiate cold water, hot water, because I don't have a lot of time in my life for that, because both are the same. But I mean, you might want to go back and do it later, right? So now these little symbols that indicates that the pipe is going up or down. Okay, uh, if you can see like the white, it typically means the pipe is going up. If it's darkened, that typically means the pipe is going down. But that's why you have good riser diagrams. And then let's see what 3 and 4 is telling us. Shut off valves. Let me see. I didn't look at the symbol. The symbol makes a difference. Oh, and I don't know where I was. Okay, no. Octagons. I gotta look for the octagons. Where's the octagon? Okay, right. 3 and 4. Yeah, yeah, that's just shut off valves. Has nothing to do with whether it's going up and down, because you have the awesome riser diagram. So the riser diagram tells us it's going up. And so you can account for that way. All right. And so I guess that's it. I mean, if you're doing this, take off, this is a good project. Civil plan, underground utilities. Once it comes into the building, you switch to the plumbing plan. And the main thing is to understand, don't forget every time you see a pipe going up, make sure you know the size of it. 10 feet, 10 feet of 1 inch, 10 feet of 3/4 inch, 10 feet, right here, 10 feet, 10 feet, 10 feet. Now remember, the horizontal measures are what's on the plan. So you're only looking at the riser diagram for the riser, right? The up and down, the vertical measure. These measures are the horizontal measures that in one way or another are reflected on the plan, in the plan view, right? So if you have any questions for this, please let me know. Please sign up for our class for plumbers only. It's $9.99 a month, and we add new content every week. If you have questions, you can sign on and have a office hour where I will answer any of your questions. If you like the video, please let us know. And we are running some specials. One, October 15th, a $100 Starbucks for all of our nice listeners. And then also free training, a contest for free training as a Thanksgiving present. And for Christmas, we're also giving away every month some free estimating if you have a company that requires estimating. So you can lose one way or another. But if you have any questions at all, please email me at education@sfjohnsonconsulting.com, and I will talk to you soon. So this is a shell for a Chipotle located here in lovely California. And we are looking for contractors to bid with us. And as you can see, we'll do your estimates for you. This is actually a shell of the building. It's not a complete interior fit out, build out, whatever they call it there. So it's just the site and the shell building. Makes it real easy. And so now, this afternoon when we present at 2 o'clock, we're going to do more of the pricings because we pretty much know how many square feet or whatever. We're going to do all from assembly pricing, so we won't break down the individual pieces of, say, like the foundation until we're ready to win and do the work and get an actual pricing foundation. Assembly prices should not be much different than individual pricing of the concrete, the rebar, and the formwork, and all together. The assembly price should not be much different. So, all right. So here's the demo plan. So it has it's in the middle of somewhere, and we have to get rid of some things first. And so let's see what 5 and 6 is. Protect, protect. Let's see what we're removing. All right, so 1 and 2. Okay, so removing a tree, it's important to know the size of the tree. And we go by the diameter of the stump or the base of the tree. That diameter of that tree, that's how they base, either putting it in or taking it out. Okay, so that's important to know. And if you don't know, it's important to find out. So can you just pull it up, right, with very little effort, or you got to cut it down? Those kind of things makes a huge difference in the world of construction. All right, so 1 and 2. Where's 1 and 2? Do we have a lot of 1 and 2? Not really. Okay. And so if this is dirt, then we don't need to saw cut anything. I don't know if it is. This may not be. On this side, this is probably. So we'll saw cut that. Include the price for our demo for saw cutting this, because this is really attached to something, just like maybe this is. I don't know. But what's the scale? On these plans, scales in a funny place. Here we go. 1 inch. Oops. Cancel that. We don't want that one. 1 inch equals 20. There we go. We agree. And so we're going to demo. We're going to 1 and 2 first. So we're going to demo curve. And in this case, we don't care if it's curved or straight. And in the afternoon session, we will be going over actual pricing. Okay, so now we want to saw cut because we don't know. We can delete that if it's no need once we win. So we think that's connected to something, but that doesn't appear to be. And so now we're going to demo. Let's just say remove concrete. We'll assume that it is reinforced, because that's how we price it. It's priced different if it's reinforced. So we're going to go like this, this. Let me go down. There we go. Come on, don't fail me. One and two, one and two. Yeah. Okay, so there's a lot of protect. So we just going with what we see remove and see. That's a big tree. Those are two big trees. Huge trees. So we have to get more details. But remove tree. Big. We'll assume that it's the biggest that the cost book gives us. I think that's 24 inches around. Alright. I think those are the only two trees. And what else is remove? Remove is a property line per lot adjustment. Remove property line. I don't know that applies to us. That's property line is just set. Yeah, we'll ignore that one. Let's see. So you give some time for field verify. Field and sewer main exists. That's your property. Okay. So we give an hour for that. Field verify location. Hour. Field verify. Hour. Abandon it. That's easy. Remain. Quit claim. Given to. Not our problem. Protect. Now the protect part we can do some protect. Go into the specifications on how they mean protect. And we have those, so we'll bring those up in the afternoon, 2 o'clock Pacific time. Remove sidewalk panels marked. Remove sidewalk panels. Oh, okay, like those metal panels probably. 17 curb and gutter. Okay, because we can measure that. Oh, look, we had more one. Alright, let's go back. Let's get this one. Alright, so, what did we say that was? The panels are 16, 17 is curb and gutter. Okay, there's the panels. 17 curb and gutter. Oh, that looks pretty. Seventeen. Then we'll just 17. Alright. And panels, sidewalk panels. And about 3 hours of side. 3 hours of verify. And that was sidewalk panels. That look kind of big. I don't know what kind of panels those are. If those are concrete. And if they are, we'll do them different once we know. And that's all the remove there is. I'm not worried about protect. So 14. Yeah. Okay, protect utility box in place. Okay. Boulders surrounding the site. Where's a separate one? I guess you just gotta go out there and see if you find some boulders because they're not marked. So wherever the boulders are, get rid of them. That's extra. So all those are things to note, but nothing to really, be able to determine because they're not shown or anything. So that's like removing a tree, depending on the size. that's that one. All right, so we go all the way down. The striping plan, really, we just now they have a stripe. Let's see. We need a concrete plan. That'd be nice. Yeah, there we go. Existing is A, so let's do pavement C, sidewalk D. Okay, let's do D. Now, when we price the sidewalk, you can price the sidewalk by the width of the sidewalk, or we can do it by square feet. So that looks to be about a 3 to 5 foot sidewalk. So let's see. We're going to do it both ways this afternoon when we come back together. So we are finished here at 11:30, which is about 10 minutes, and whenever we don't finish here, we'll finish then. All right. So scale, always scale. And I know my sets of plans are always good, so I don't worry if they're correct. All right, so sidewalk was D. Let's see what the width of the sidewalk approximately, because you can price it by the width of the sidewalk. It's a 6 foot, not even 6 foot. I go by 6 feet because it's closer, but then you got to make sure they're all 6 feet. See, that's 6 feet. D, now that don't look 6 feet. See, that's 5 feet. 6 feet, what's that? Is that a special? That's a special kind. That's a curve right there. So, can we use all 6 feet? Or just measure how many linear feet? You know what? I'm going to use 6 foot wide concrete sidewalk, because that's how we price it. 6 foot sidewalk, instead of doing it by the square foot, because that's we're going to do everything assembly price. So it goes pretty much from here to here, and then from here to there. We're going to just give it extra. Always give it extra. Here to there, and then there. To the front door. D. Then we got some right here. Might as well finish it up right there. We got some right there. That's patio area. I'm going to make that different. And do we do all D though? Yeah. Alright. So that's the sidewalk. And then C was parking pavement. We're going to do that by square foot. We'll call that parking. And then we'll go by cost book wise, what it tells us. So we're just going to include all of that, because this gray is different. It looks like we have curve too. We need to determine how many linear feet. Lots of. Hey guys. Hey everyone, this is Stacy again, and we are still on the same project. Our repair facility for crashes. Let's put it that way. And now we're looking at the plumbing plan. So because it's not a big, there's no really huge need for the plumbing aspect. So what we're seeing here is it's important. They're giving us a couple of call outs here and here, and then this is the piping that's running through the main building, and then we have some standalone eye wash stations, and then these call outs are actually right here. And so what's important is to make sure when you're doing the takeoff that you note the scale. So you can't use the same scale for this full set and then these separately because they are of different scales. So we can measure one scale or whatever, but when it comes to actually, recording the actual numbers, we need to make sure if we're recording the numbers for the upper that we have the scale set to 1/8. Okay, so now we have, these are accurate measurements. And for this, so this one's going to be a little tricky because they're both on the same page. This is 1/8, so you could double, or no, this is 1/4. So you can double that and use all of 1/4 scale, but I don't do that. What we have to do is do each one separately, and when we print it, just note that you have to print it differently for the different scales. And so, because this is new construction, or this is existing, we have to note if we have in our plumbing plans, if the plumbing here is actually new, or are we replacing existing plumbing? Because if it is new, because this is the existing building, this is the new construction. So if we're just replacing, and that's why I say this, if we're just replacing sinks, water closets, and lavs, then we don't need to incorporate the rough-in costs. But if they're actually new, then yes, we do. So what we need to do is go back to remind myself and go back to the building demo plan. Let's turn off some of these colors. Right. Let's turn off. Yeah, no, there's no bathrooms. This is the demo. There are no bathrooms in here. Those are all new bathrooms.